Coming. I'm Christopher Shank. I'm the director of the School of Game Design, and I'm very happy to see all of you here for this fabulous event. Before we start, a couple of things. Please take the time now to turn off your cell phones or turn them down. Also, I'd like to thank President Lisa Stevens for giving us this venue and the opportunity to have our guest. And I'd also like to thank our School of Game Design faculty and staff, David Goodwine, Charlie Hunegard, Bryce Jones, Jeremy Rowland, who couldn't be here tonight, but without him, we wouldn't have had this opportunity. And last but not least, Megan Carlson for helping us put this on. So, yes, thank you. Thank you, guys. Okay, that's enough. Don't encourage them. So we have a fabulous guest tonight who's the lead technical artist at Naughty Dog, responsible for the Uncharted 3 and the Uncharted series, which we all love, and I'm sure we're excited to see it. Please welcome Teagan Morrison.
Hello. Thank you, Christopher. Well, it's good to be here. I appreciate the opportunity to talk to you guys and to spread the good word about Uncharted 3. There will be a little bit of advertising somewhere hidden amongst the slides. You won't know it hit you. Yeah, as Christopher said, I'm lead technical artist for Naughty Dog. And this talk is primarily about environments. In fact, an alternate title for this talk was Real-Time Environments Made in Real Time, because it's not just about making environments, it's about making them in a reasonable amount of time, because at Naughty Dog we have some pretty intense development cycles, as you might have figured from the games we put out in the time that we put them out in. So I guess the top title of the talk, Wonder Tag Ties and T-Frag, is I guess it's just a little sort of a morsel of Naughty Dog speak, in the sense that those words don't really exist out of Naughty Dog and have sort of grown out of necessity to describe these new grounds that we're walking on. I'll reveal the meaning of those words during the talk. And I also think it's rather appropriate that we're doing this in a church, because as video game developers, we kind of are playing God, creating entirely new realities, some of which are more pleasing than the real world in some circumstances. So without further ado, let's, I guess, start the talk. Oh, as if that wasn't started already. What are the goals? Well, insight into the tools and workflow used to create the environments at Naughty Dog specifically. Using them as examples, getting environments to run in real time and getting them to done in real time, real amounts of time. As a lead technical artist, I have to deal a lot with, let's just get this up, a lot with performance and the resource usage from different departments across the game. So getting them to run in framerate is a really big part of my job, and I'll be hopefully peppering morsels of optimization in amongst the art-related slides. And how to make environments awesome. It's a little bit of a saying at Naughty Dog. As cheesy as it is, we say, let's make it awesome. Is it awesome yet? No? Okay, we should probably keep working on that then. And it turns out, though, there's a little bit more to making something awesome than just throwing everything at it. And part of that is knowing when to make something not awesome, believe it or not. So we'll talk a little bit about that too. And not included, though, how to use software. There are instruction manuals, there are many, many videos online. I wanted to give a little bit of an insight that you can't pick up reading Maya's help tutorials. There's me looking maybe sheepish, I'm not sure if that's the right word. Game of the year, by the way, Uncharted 2. I hope you've all played it. Who's played it? Yeah! All right, Uncharted. I like being in a crowd of people who have heard of it, because despite its critical success, not as many people have heard of it as I'd like. So spread the good word. right? I make games, and I mean that in a very broad sense, in that there are very few aspects of game creation that I don't have my hand in some sense. And like I said before, I'm lead technical artist for Naughty Dog. Since you're mostly students, you might all be interested in sort of where I came from and how I got to where I am today. The accent is, yes, from Britain. I grew up in Southampton and moved to America when I was 16. Unfortunately, I've been growing tall, so I keep needing to make this a bit taller. This was the first environment I ever made. It was when I was 16, actually, on 3D Studio Max, I think 2.0 or 3.0. And as you can see, it's fabulous. Just check out that purple sky. Really makes sense in that scene. I don't know what that is on the right. Is that a picture frame with some white and pink in it? I have no idea what that is. As you can see, there are some problems with it, and I could critique it for hours and get a lot of laughs out of it. But I think it's appropriate to show, given we all have to start somewhere. I actually never officially went to school for art in any way. I was actually a programmer at Santa Monica College, and I did most of my art at home. This was a personal project just to learn 3D Studio Max. Although I quickly morphed into something that was a little bit more immediately profitable, being in the United States and not being allowed to work for visa reasons, I turned to website design. And ultimately, though, despite me and a friend creating a website design company that was fairly successful for our purposes, I was as skeptical of my future in web design as I am of Feng Shui. So I moved on from that to selling commercial 3D models. This is a site called Turbo Squid. But I also made my own model site. Convenient background in website design helped with that. And I'd highly recommend for anyone who likes just to make 3D models, go out there and sell them, because there's like a high demand for models that you can just buy straight up, and it'll force you to kind of professionally package them. And yes, over to the right, that is a turd. I made shit and I sold it to people. So yeah, I'd highly recommend going for that. It's also a great source of passive income. So if you spend a couple of years making models that you sell online, you can keep making money from them for years to come, which is kind of useful. I also do a lot of programming in my free time. I make software and iPhone games and all sorts of things. This was a first-person shooter I made in XNA, the goal being from scratch completely to implement all the systems of networking, split-screen, multiplayer, AI, all in very, very crude form, just to get a taste of everything. I'd highly recommend XNA to anyone who just wants to sort of delve into stuff a little bit deeper without going incredibly low level. There's still a lot you have to implement yourself and understand. So let's talk about sort of my professional experience. The first job I had was at Naughty Dog and working on Uncharted Drake's Fortune as an environment artist. Naughty Dog, they provide a test. So experience is not so important. It's really about what you can prove you can do in your portfolio and in the Naughty Dog test. And my hiring practices at this point really kind of go back to how I started at Naughty Dog, which is it's all about your ability to prove how good you are, and much, much less about sort of your experience or where you went to school, which I think is cool. It kind of puts everyone on a how talented are you level rather than a sort of what pedigree do you come from level. And it worked out for me because growing up in Santa Monica, well, once I got to the US, where Naughty Dog's located, it turned out that my favorite studio was just down the road, and they would let me take a test. So having graduated with a degree in computer science, I decided to go for a job as an environment modeler. which it turns out is something you can prove you're good at just a little bit easier than programming. The first level I worked on, if anyone's familiar with it, in Uncharted, was the Jeep chase sequence. And I also did the monastery sequence near the end of the game. Uncharted 2, I was lead environment artist, and I kind of led the team and tried to sort of be a bit of a trendsetter in terms of the environments we produced. I worked on the Warzone look very, very extensively, along with sort of having my hand in a lot of the other areas of the game. And let's just get a taste for Uncharted 2, just for those who aren't familiar. Very quiet afterwards. I'm showing you this level because we'll be using similar pieces that were made to make this one, and kind of getting familiar with just how this one came to be from start to finish. I think the audio has literally gone completely now. That's okay. It seems that most of you already played it anyway. Yeah? Who hasn't? Who's brave enough to admit they haven't? Alright, let's move on. And Uncharted 3, hopefully the game that some of you are waiting for, which will be shipping in a couple of weeks, November the 1st. I was lead technical artist, so I was responsible for a lot of the environment still, for scheduling a large portion of the art team, and frame rate and technology and tools across the entire game. Let's watch actually the trailer for Uncharted 3, if you're all into it. This isn't advertising for it, this is educational. Yeah. Well, hopefully we succeeded in making it awesome, but you can judge for yourself sooner or later. Hopefully sooner. Hold on while I adjust the presentation style. Unfortunately, I had some technical difficulties last night with video playback, and I resorted to a contingency plan I had to implement on the plane. It was very Mission Impossible. which will involve opening external videos and a less pleasurable experience for all of you. So my apologies. Just in wherever you are. I got it right. Okay. Okay, cool. Let's talk about professions at Naughty Dog and how we break down the tasks by title. Now, this is very, very simplified. The lines between these tasks, these titles, are very blurry, and there's a lot of crossover and there's a lot of gray areas. So don't get too hung up on these things, but generally we do assign kind of a title just so people know what to focus on, which is the kind of the point of specialization. The more you focus on it, the better you are, and the bigger the games come and the harder they are to make, the more people need to specialize to make stuff awesome. And also a big kind of myth with all of with these different departments is that there's an order to the workflow, as in sort of background modeler makes the models, then the texture shader artist puts the textures on it, and then the prop artist makes the props around the models. But everything happens a lot more at the same time. It tends to happen kind of all at once, at least at Naughty Dog. So we'll talk a little bit about that. Let's, I guess, go into depth about individual background modeler first. What do they do? This is going to be sort of the main focus of this talk. I'm going to touch on texture artist and a few of the other professions, but ultimately it's going to be about background modeling and kind of more of an overview of everything. They model the environment, kind of obvious there. It's funny, actually, in the credits of Uncharted 3, originally it said background modeler, and there was a lot of fuss. Hey, we're artists too, they said, so maybe background artist is more appropriate. But they also manage models and prototypes, which is no easy task. There are lots of those to keep track of. And they compose the scene, which probably is actually the most important thing they do. Is take a lot of the elements that they've created already exist and put them together to form coherent levels. That's primarily what we're going to be doing today in some of the videos, because making any one individual piece is usually fairly straightforward and simple. There are sort of tutorials everywhere for that kind of thing, but how do you put that all together in a time-efficient way, I think is important information. They also create collision. And do a bunch of other things sort of related to managing backgrounds. They're kind of the hub of the background, if you will. And let's also talk a little bit about shader artists. They paint and sculpt textures. Now, notice that sort of the keyword sculpts, and that there's actually a lot of 3D work involved for texture artists. It involves kind of creating 3D models that are fully formed, painting them, but then perhaps baking them down to flat surfaces, and in some cases, not so much. It's actually, I think, one of the more overlooked avenues, and I highly recommend anyone who likes sculpting to kind of start looking at sort of texture shader artists as a legitimate option for that, because a lot of people say, oh, I'm going to be a background modeler. Well, what do you do? I work in ZBrush all day. I love ZBrush. I love sculpting. Well, you're probably going to be better off perhaps working as a shader artist. So just an idea. And they also manage and customize shaders. Notice the specific word customize. Funny story, maybe. The call I got from Naughty Dog before I started there from the art director was very early in the morning, and I leaped out of bed naked. And the first thing they say is, so you want to be a you want to work on shaders. And my response was, I haven't done any shader programming. I don't know how to make shaders, although since I've done quite a bit of shader programming, but that was a little bit deceptive because texture shader artists don't necessarily make shaders. The extent really is kind of a noodle graph. For any of you, those who've used Unreal's Noodler, we have a similar thing to that at Naughty Dog, and also a very simplified version that just involves adding features, usually for optimization. And they also apply shaders, UVs, and blend values, although ZBrush is definitely the primary domain of the texture shader artist. Let's talk a little about prop object artists. Unfortunately, at Naughty Dog, it's a little bit of a sort of kind of a dying profession in the sense that a lot of our props and objects are now outsourced. It turns out you can sort of very easily describe them, especially when you're making a realistic-ish game. And they're also, how to make them is usually very, very kind of defined. We all know how to put together, once you've made a couple, you can kind of make almost anything. So we do get a lot of people who apply with mostly this kind of thing on their portfolio. I'd recommend just trying to expand beyond that. How can you put a lot of this stuff together in a coherent scene? Or make it move, which is one of the other things we'll get into in a second. Lighting artists, they are responsible completely for lighting. They also do a lot of the runtime stuff. For instance, fog settings and color settings and depth of field and sort of even wind, anything that involves just settings on a per level basis. Dynamic foreground artists, usually, actually, we've been kind of splitting these two. We have people who concentrate on dynamics and people who concentrate on foreground, but they deal with a lot of things. Basically, if it's solid, it's not a character and it moves, a foreground artist has set it up in some way. And by solid, I mean it's not like alpha blended, so it wouldn't be a particle artist. Dynamics, I think, is a very kind of emerging field in the video game industry. So if you like blowing stuff up, and who doesn't, right? Dynamics might be for you, and we definitely sort of have created that position over the course of the Uncharted franchise, just people who are expert at making things explode. And of course, FX particle artists deal with all the particles. Both dynamic and foreground artists and effects artists, a little bit kind of half environment, half not. Just why I had them sort of a different color in the earlier view. All right, let's sort of take a journey through the magical rainbow process of making an incredible environment. Of course, I'm a little bit liberal on the rainbow there. It's filled with both strife and excitement. So starting ideas, like where does it all begin? And this sort of journey we're going to go on is a little bit indicative of what we went through on Uncharted 2 and sort of the process that created some of the environments, hopefully environments that you've enjoyed and loved. But so where does it start? A lot of, again, there's this kind of misconception that there's a conveyor belt kind of aspect to this, and that story comes up with the story and then gives it to design, and then design gives it to concept, and concept gives it to an environment artist, and so on. But it's far, far more organic, and really everyone's kind of riffing ideas off each other, all working on it at the same time. In fact, when we started on Warzone, which is going to be the primary look we're going to talk about today, we had very little story, or we knew that it was in a Nepalese kind of town that had been kind of destroyed, had been ravaged by war. We knew little about what Drake was going to do in it, although one thing we guessed, using our brilliant intuition, is that he was going to walk through it and fight through it in some way. So, based on that assumption, we sort of started putting some stuff together. And everyone sort of started working on it at the same time. In fact, that design view you see there had multiple iterations while the art was being done, and was influenced quite heavily from it. Let's kind of go right back to the beginning, though. Like, what was those initial sparks for the idea? The initial kind of idea that there's going to be the story based in this Nepalese city concept is not necessarily the beginning. Photo reference, we just kind of really immersed ourselves in photo reference. Thousands and thousands of pictures. And we're talking days and days and days of just looking at nothing but photo reference, to the point that that's all you can see in your dreams. It's not that bad. But there is a lot. And it's actually funny, after the release of Uncharted 2, a fan put up this comparison between, I think, Kathmandu in this case, and our vision of the Nepalese war zone. And some of the similarities are quite uncanny, just because they found photos just like we did. They found exactly the same photos in some cases. Although we also actually had some people go to Nepal and take photos, which was kind of cool. A lot of the early stages is just kind of picking pieces of photograph that you like, elements in them that, hey, you know what, let's make this. This is going to be cool. And we'd sort of start a folder full of them. My favorite way to work is a sort of a to-build folder that just contains a bunch of photographs that some element in them is something I want to put into the game, like that building at the top right, even with the pots, very cool. Those like the spices and stuff on the left. Awesome. Actually, all of these things made up into the game in some way or another. But photo reference is not the boss of you. The biggest mistake people can make is saying, well, I saw it in real life, or I see it in the photo reference, therefore it's correct. But if it looks bad, or it's not as awesome as it can be, then it doesn't matter how real it is. For example, that photo at the top left of that broken building, it has not broken in a very aesthetically pleasing way. Now, we can, of course, ask it to break in an aesthetically pleasing way, but when we're kind of creating this hyper-realized version of reality, we can definitely make it a little bit more cascading and a little bit more artistic and give it some flow and some sort of some interest to it beyond that. And then other sort of examples, the stall of the statues at the top right, that's not something you'd probably want to put in a video game, just because it wouldn't read and it would be incredibly expensive. Maybe one day, but on our current gen hardware, that would just not be practical. And then another example, those wires at the bottom right, although kind of interesting and very, very kind of messy, don't read that well. You could probably clump them into much more interesting ways. And the same goes for those dolls in the lower middle. They just wouldn't read well. The majority of the time, you're just going to see that as a big blur of color. So selectively picking things to do and not to do, more importantly. Another example, that building in the lower left is just kind of too modern. We wanted to give it this old-timey feel. And although there are a lot of modern aspects in Nepal, now they just weren't going to create as interesting a feel. Now let's look at concept, which at the same time is gathering a bunch of photo reference. Concept artists are trying to kind of do what I was describing, taking those, say that broken building and saying, how do we make this aesthetically pleasing? So you see the kind of the waterfall, the cascade of rubble coming down from the side of the building, which is really cool. This is actually one of my favorite concept pieces ever done for Uncharted, mostly because it's just full, over brimming with ideas. We're talking subtle ideas from how the bus looks slightly grumpy, the way that the Nepalese prayer flags hang in such a kind of arcing way, the choice to kind of ironically put a stop sign above the bus, and all the sort of the interaction between everything is really quite amazing. I kind of judge concept based on the number of ideas in it. If it's just full of them, then it's great. If it has very few ideas, but it's very well executed, isn't necessarily very useful. In fact, just as a sort of an overall kind of philosophy for Uncharted is realistically immersive. Like, you want the player to believe that this could exist in the real world, but unrealistically awesome. You want to take the real world and you want to twist it until it is cool and awesome and way more interesting. You want to find those aspects of the real world that you can kind of exaggerate and punctuate to create the final result. I love the little caption under undulating smoke shadows on the ground. It's too small to read, and I can't remember what it said exactly. Just use the power of your imagination to imagine them, or something like that. And then that apartment kitchen on the right, if you see the original photograph and kind of the paint over of the photograph and just where we took it, making it a lot more colorful and a lot more interesting, and adding some sort of rich elements that might not necessarily have existed in real life. And concept isn't a product, it's a tool. And I know that's kind of a grim reality for those who want to be concept artists, but you are creating tools, not pieces. In that its usefulness is far more important than its aesthetics. My favorite concept story of all time was one of our concept artists who, on a napkin, scribbled the front of the hotel that you climb up in Uncharted 2 in 2 seconds. And the idea was conveyed, and we made it, and it was great. That was all the concept we got on a napkin. Wish I had a picture of that. Here's another example of just like, hey, let's just scribble on top of this design and get an idea for it without anything fancy, without anything colorful. 10 minutes, and ideas are conveyed. And sometimes it just means creating a lot of good photo reference. If a concept artist can really prune and pick between the vast amount of photo reference out there, then they can really fuel the level. But I think it's easy to overlook these aspects, and as a concept artist, just concentrate on portfolio pieces. So not so useful if the concept follows design too closely. If you paint straight over some sort of block gray mesh, you're not going to get anywhere near the results you would want. In fact, as a concept artist, you need to understand how the game is going to play and what the elements of the design are, so that you can pretty much boil down what you see to the bare minimum and paint around it with the most kind of leeway possible. If you follow real life or photo reference too closely, you might as well not do the concept art at all. Ideations, I'm just not a fan of them for environments because there tends to be so much environment, you can't possibly concept all of it anyway. So why spend a lot of time ideating just for one area of it? Of course, though, there are exceptions to this. It just happens to be that we're quite a realistic game. So under those circumstances, they're not as useful. And then other concepts that are like really weird camera angles or sort of top-down. I'm not a big fan of those just because they can tend to look awesome on the merits of their camera angle alone, and when you translate it into game from the player's perspective, not so fun. All right, let's sort of start working on an environment. Let's say that a designer has just given us this block mesh. And the first thing we want to do is look around it. Let's have a play of this thing. All right, just a small street by the looks of things. Perhaps that building to the side could be a broken building. I guess it wouldn't really make sense any other way. That big block there, what the hell could that be though? We'll have to figure that one out too. Seems like a sizable amount to make. So we're going to take this block mesh and we're going to turn it into a finished product in 3 hours, or at least that's the amount of time that it took me to make it. That would be a little bit fast for a real production environment. This would, I guess, be closest resembling what we'd be doing close to crunch time, like when we're just about to ship. Oh no, there's a missing part of the game. Let's make it in the next couple of days before we go gold master. That's what, sort of the circumstances under which we'll be making this. All right, this is where I have to apologize because I'm going to have to launch these separately, unfortunately. All right, let's take a look at the block mesh in Maya. Notice how really simple it is. And all it's doing is conveying the idea that there needs to be cover there and a street there and a building to the side. There really isn't any artistic detail. And I think the simpler the block mesh can be from a design standpoint, the more kind of freedom the artist has to kind of interpret it. As soon as you start putting in details, it's sometimes very easy not to look beyond those details and just to get hung up on them. Let's look at that process a little bit more in depth with another example after we close this. All right. This is for the Papua Swamp level of Uncharted 2. And this was the block mesh that the designer created. Maybe a little bit art heavy for my liking, but pretty much there in terms of just where the boundaries should be. This isn't necessarily something we do, but it's definitely something you do in your mind, using the power of your imagination. It's trying to kind of go beyond what you see in the block mesh. Like that giant root kind of climbing all over it was definitely not something the original design contained, but let's see if we can push it in that direction. And this, I guess, was just an example of kind of just playing with shapes in Maya. Not necessarily creating anything final, but just, is that going to work? Is that going to look cool? Let's just create some really, really rough things. It doesn't usually happen this way. This is a kind of an idealized version of our workflow. It's a lot more kind of messy, if you will. And this is the final Maya mesh and the final in-game. Let's look at something else. Look at this piece of concept. Not actually my favorite. Just because a lot of those buildings are very, very similar, in that you get kind of the idea for one of the buildings and then not necessarily an idea for the whole level. And let's look at a piece of block mesh that concept was made for. Okay, so we've probably got some buildings around for this village. But let's just talk about this kind of line of buildings here. Sure, it could be a line of buildings, so all similar heights. But it could also be... it could be some rocks, who knows? It could be an overlook of a cliff. But what we kind of settled on, let's try to just hybridize all of this to create more interesting silhouettes, create sort of a combination of all the good ideas. And this was kind of the final results. And notice how much more of an interesting silhouette that ends up being, rather than being kind of pigeonholed into the middle of a village. Let's get back to our level, and before we start making anything in it, I just want to sort of point out the importance of having something for scale. Terrible mistakes have been made without scale being kept in mind, and the first thing most people should do, and I didn't, I'm terrible, is bring in something for scale, just so you can put it up next to everything and make sure it all feels right. Luckily, we're going to be using mostly prototypes that already exist, and the scale is fairly well defined, so it wasn't as big of an issue this time around. There we go. All right, so this is me looking through the vast prototype library for the Warzone look. And what I did was just select a bunch of them and drag them straight in. This is a sort of a prototype browser that I created specifically to manage them, and it's using our RefNode system that I'll get to in a minute. And let's sort of start placing them. The idea, though, is to build up a kind of a palette of prototypes. So off to the side is a bunch of pieces that I just kind of had a feeling that maybe would come in useful for this. Like this building facade is going to come in very, very useful in this case. There are quite a few other building facades that I'll also bring in. And I'm really just going to start blocking out some of the big shapes. What kind of big buildings do we already have that we can use to flesh this environment out? Now, I'm not going to get into sort of how did we make any one of these buildings, because by themselves, they're actually fairly easy to make. I mean, you saw the photo reference earlier that had some of these buildings kind of highlighted and circled, and actually modeling them is kind of, it's just a bunch of hard surfaces, and you can make them with just 2 or 3 polygon tools. It really isn't that big a deal. But it's like how they fit into the big world that ends up being very important. And quite often the big mistake is to try to get really fancy with your prototype system. So you make sort of individual windows and ledges, and sort of you get all intricate. In this case, we found the best way was just keep it simple. One building, one prototype. And let's in fact talk about prototypes. So a prototype is kind of like just one mesh until it ends up in game. And then it's an instance. It's sort of a copy of that prototype that exists. That you can see, and we use a lot of them in game. We use prototypes for quite a few different reasons. First, tie. The word tie that I mentioned in our title is a word that we use for prototype. I don't think prototype existed at the time, and it comes from legacy, I think Jack and Daxter stuff, or actually maybe in Crash Bandicoot, but I'm not entirely sure of its origins. One of the reasons we use prototypes is because in game it's a lot more efficient to instance things. So maybe the original prototype from a memory standpoint cost 14K, but each instance only costs 2K. The reason being that every time you instance it, you only need to pay for the lighting data involved, the unique data associated with that prototype, and not the sort of the original cost. And also rendering them is a lot more efficient. But easily overlooked is that each prototype maybe only took 30 seconds to place. Well, the original one maybe took 30 minutes, maybe it took 3 days. And that placing prototypes gets you way, way more bang for your buck in terms of time to result ratio than making them. Which is kind of why I always want to stress, like, getting to the point where you can create a world with prototypes very quickly is sort of the goal of environment art. Is like, how do you create that tool set? Any one tool is particularly easy to create, but how do you create that in a way that's going to let you create unique, awesome environments very quickly? Another reason to use prototypes, of course, is to modify them and have that modification ripple across all the instances. For any of those who've used Max's XRefs or Maya's referencing, we use a very similar system. Ours is a little bit more simplified and kind of used so that we can put custom data on it. But it's as simple as a Maya node with the mesh parented under it, the Maya node pointing to a different Maya file, and you can bring in that Maya file or get rid of it. Sort of a more complicated example would be this rickshaw. The wheels are all ref nodes, so they are the same, so the instances. And say these details, which are actually on their own ref node, were put there so that they could be faded out, like that at a distance. And let's keep working on this. It turns out that a lot of kind of, once you've got all the prototypes down, a lot of the creation just involves kind of seaming them all together with tfrag. And I would deliberately put emphasis on that word because no one will have heard of its meaning, which we'll go into in a minute. This is, let's create this sort of street. And notice that although it's very, very, very simple at first, the whole street is kind of there. Now this is kind of a modeling style which involves, let's make the simplest, biggest brushstrokes possible, and then start working on the details. It's very easy to get kind of carried away and immediately start like putting in street curbs and dents and all those details, because we love details as artists, of course. But kind of try to stay away from that. In the long run, it's going to help you a lot more. In this case, it was just a nice kind of sort of good edge flow. So you can cut in edges. Use edge loops to your advantage. They are incredibly helpful, incredibly powerful for speed. And Maya has a lot of, most 3D modeling packages have good edge selection options. So although I'm working on this whole street, I'm really kind of using the power of edge loops to maintain good topology and create it very quickly. Now, a very, very common mistake in environment art is to leave the ground flat. We're all sort of making stuff in rooms where the ground is flat most of the time. But in kind of the real world, out there in all these spaces that are usually depicted in environment art, the ground is all over the place. And although it might not be obvious, you might think, okay, a street's fairly flat. Streets aren't flat. They're actually usually curved in some way or another. Although, mind you, being in San Francisco with all the hills is, maybe not that surprising. Like I promised, I'll give you what tfrag means. We've started using it at Naughty Dog quite a while ago, and it comes from a technical term coined during the Jack and Daxter engine days. Just really through lack of a better word. If anyone has a better word for describing unique geometry that isn't instanced, that's just used the once, that sort of your time is just being put into this one place and it's not going to get any reuse. If anyone has a better word for that, I'd love to hear it. As it is, let's maybe try to coin tfrag. Although it's lost its original use, it still kind of maybe means something appropriate in that it will destroy your time. The more unique geometry you have in a place, the more sort of time expensive it's going to be to make. Let's actually look at a few bits of Warzone and like how much unique geometry is in there. It turns out this is all that's left once you take out the instances, and that everything else in that scene, with a few exceptions, is used somewhere else. So it's actually very, very light on the tfrag, which is a good thing. So we're going to be trying to do that in the environment we're making today. So again, another example in Shambhala. And that's all that's left. And that's a pretty expensive piece of Teagan, and there's a lot of mesh there, and there's a lot of seamed up that needs to be done. But ultimately, a very small portion of the scene. There we go. So putting in our curve in the road, let's start sort of blocking in some of the other elements. Remember that block we had no idea what it was? It could be a lot of things, but let's say we talked to the designer and they were like, yeah, this area is not doing so well. We're, in the middle of the war zone here. Let's instead then tell a story with that block. It doesn't have to be, a newbie mistake maybe would be to make it a weird extension of that building. But no, let's make it into this car, and let's say, this car's come around that corner pretty fast and gone straight into that fire hydrant. And that's what we call it, just a little story. Of course, you could take it a lot further. But ultimately, let's figure that down. Ultimately, telling stories in an environment is really important. Uncharted is kind of all about the story. It's all about sort of experiencing that. But so should the environment tell that story. It shouldn't just house the game, but if you look around the environment, the richer it is, the more stories you're going to kind of pick up from. And here's a sort of another example in the actual game is that bus tripped over that fire hydrant and kind of bust it, and now it's watering out to that hole that maybe with the, gas main. There are lots of kind of inferences that can be made, but ultimately quite interesting because it all works together coherently. Another one, this building has clearly been like bombed and busted out, and the rubble is just cascading all the way down from it. So it sort of creates a coherent piece. One of my favorite, the toilet fountain. Water cascading all the way from the top of the toilet, all the way down to the bath that's fallen through the floor. And so, yeah, the same, the truck that's crashed through and its light is still blinking. The laundromat and internet cafe that's been busted down and water is pouring out of the laundry machines. Sure, some of this isn't necessarily realistic, but it makes for a more interesting environment. And that's even sort of cascading down the back of the laundromat all the way down the stairs. So kind of creating this coherence to it. And you can always go further. You can always make sure that all the stains are in the right places and that the detail is just there to support everything you want to say. But ultimately, getting this kind of thing in at all has a lot more of it has a very positive impact, I think. Sort of even down to the way that things are destroyed. Like maybe there was a volley of shells that came cascading across this building, or maybe it cracked open. But there's sort of a coherence to the way it's destroyed. The temptation is often just to kind of pepper things with bullet holes, with holes, rather than to try to kind of create a rhythm and a flow to them. All right, let's bring in some of these rubble pieces, just to kind of support the idea that maybe this car bashed into something, created a bit of rubble, or it's debris that's maybe collected underneath the car. And notice that these rubble pieces actually were brought on in just one ref node, so they count as just one prototype, but I am individually placing them. This is something that I'll talk about in a second, which is a very, very powerful tool we have at our disposal. So, like I said, move mods. With just one prototype, we can, every time we instance it, create a lot of different sort of placements of the individual pieces. Sort of that allowed us in scenes like this to, and I counted, not by hand, that there were over 5,000 hand-placed elements in the background in this scene. We would not have been able to handle that many individual instances. But because of move mods, because of that ability to place individual pieces of an instance, we were able to get so many hand-placed pieces. These are actually all of them. A lot of that rubble, a lot of sort of anything that you can group together with multiple pieces. And the way our engine handles it, and it's actually incredibly powerful, and I'm surprised it hasn't taken on more in the rest of the industry, is by jointing any individual mesh and sort of skinning it at runtime. So we actually have a lot of skinned environments. Oddly enough, and sometimes a little bit more literally, in the sense that these roots in Shambhala actually jointed. And as a result of that, you can kind of flow them across the geometry in really, really cool ways. This doesn't just help your ability to make environments with this stuff really quickly. It also is very efficient because you can use the same thing again and again. Now, I will admit, though, that this is a very PS3 kind of specific thing. In the bang for our buck on this is way, way worth it on the PS3, but it might not necessarily be so much so beneficial on something that's, I think, like the Xbox, which shares resources in a way that the PS3 doesn't. Let's move on. All right, let's keep placing. Now, I don't know how sort of most other people's workflows are, but if you haven't started using sort of hotkeys for the general movement of prototypes, if you're not hotkeying that stuff, then you've got to start. Clicking buttons for anything that you do 1,000 times to get something placed is pretty awful. And in Maya, actually, notice that the mouse never goes near that the manipulator. It's because Maya has an awesome middle mouse button that whenever something is yellow, using that middle mouse button is going to manipulate it. And shift middle mouse dragging in a direction snaps to one axis. If you're not doing this, do this. In whatever program you're using, find a way to make that efficient, because you're doing it thousands and thousands of times a day. And that'll quadruple the amount of time it takes you to make stuff. If you don't sort of work on your workflow, which is very important. So let's talk about interface. That's my keyboard after the end of Uncharted 2. No, I'm kidding. It's not. And also, why would I be using the directional keys? But do get hotkeys going. Make hotkeys. I can't believe how often people overlook this. And take advantage of gesture controls, because you can get a lot more out of one hotkey. And it's also sometimes a lot easier to associate a direction with an action rather than just a random key. Set them up yourself. And don't use the defaults because it'll help you remember them. And hide the interface. You don't need the interface if you're working professionally. You really don't. You have to learn it all without it. And hiding it immediately and sort of spanking yourself on the wrist whenever you want to go into those menus is going to be immensely helpful for the speed of your workflow. This is my desk. Actually, it's a mirror of my desk at home, but same thing. Those are the hidden menus, the ergonomic keyboard. That to the left is actually my favorite keyboard of them all. It's a customizable keyboard. You can pull off individual keys and put them wherever you want. So it's customized exactly to my hand and fits perfectly. No one else can use it, and there are no labels on the keys, and everyone is like, what do you do with that? And I'm like, well, I made it for myself, so it's very useful. And also, for those who kind of are doing this a lot, carpal tunnel kind of wrist strain is a huge deal. Kind of make it a priority to make your work space comfortable right from the beginning. I know we want to be kind of suffering artists in pain, but let's just try to avoid the long-term ramifications of that. And just as an example, tilting my mouse pad just slightly made a huge difference in how comfortable and actually kind of slowly reversed some of the wrist strain problems that were happening. All right, let's get back in. Here I'm just bringing in a piece of TFRAG ground from one of the other levels in a rather futile, actually, attempt to show reuse of geometry. Quite a lot of the ground in Warzone, once the initial TFRAG piece was made, was just sort of finished by pulling and sort of stitching pieces together. So, like, why start from scratch when you have something that works already? So just because it's TFRAG doesn't mean you can't reuse it. Especially just because it's not prototyped. This one, though, failed miserably. At a point, I realized that this was far too the topology just wasn't right at all for the ground here, especially considering I decided that I wanted a tile for the interior of this building and not a concrete road, of course. So I actually ended up redoing this to get better topology for the tiles that I'm just about to painstakingly cut in for some reasons, probably really late at night or something. Let's X that. But let's just talk about shaders, I guess, in general. This is a screenshot of our shader editor we call Surfer. And it's actually very, very simple. You see the shaders to the left. You see the shader features at the top. So we're talking things like specular and sort of normal maps and more advanced things. And then down the bottom are sets of textures that are plugged into some of those features. In this case, it's a blend texture, blend shader, and we'll talk about that later. I expect anyone who's used Unreal will be kind of familiar with this simpler approach and more advanced approaches. But we kind of keep it simple, mostly because we haven't really found the bounds of this kind of system, although we did revamp the organization of it for Uncharted 3. Let's talk about textures a bit first. Most of our textures have a normal map and a color map. In this case, they're made one-to-one. One was sculpted, and then the color was painted on top. Oh, whoa! Sudden unexpected quiz question number 1. Can anyone answer it? Hands up if you think you can answer it. Gentleman at the back in the blue shirt. I'm sorry? Nope. Anyone else? Grey shirt at the front. Getting closer. And by the way, the prize for this is a T-shirt and a Naughty Dog mug. I don't have great swag, but it's still a bit of an incentive. Gentleman at the front of the left. Getting even closer. I want more specifics than that, though. In the middle, in the brown shirt. I'm sorry? Just a flat normal. That is close enough, unless the gentleman right at the back can give me a really specific answer. I'm going to go with just a flat normal. Although the more technical term would be a vector pointing directly up. That value is actually kind of the blue that you see when a normal map is very flat. And each one of those pixels represents a vector. In this case, it represents a vector pointing directly upwards. Learn about normal maps, guys. Or maybe you just don't care enough about Naughty Dog swag. All right, moving on. Be ready for the next one. It'll be as sudden and unexpected. Yeah, gentlemen in the middle, come up after the talk and collect some reward. Spec masks, we've all heard of all of these. I don't really know why we have to go through them. Height maps, we don't actually use them that often for their original purpose, which would be kind of like bump or displacement of parallax. We usually use them for blend masks, kind of threshold maps, and I'll talk about that a little bit later. In this case, this texture was sculpted in ZBrush, so kind of the height map was really the source of everything, and then the color map was painted on top of that. Ambient occlusion maps, this middle one was actually generated from the normal map using a tool I wrote before Crazy Bump. That's right. And blend maps, which I'll go into in depth later. As a color map, let's talk a little bit about normal map generation. What I see all over the place is people using either Crazy Bump or an equivalent to generate normal maps. And at Naughty Dog, we're a little bit fed up of seeing this, because ultimately the normal maps are not going to be as good. They may work, they may kind of get the job done, but they are far from as good as they could be. And let me just sort of demonstrate why. Let's look at actually Crazy Bump example of that. It's not actually bad. It does a fairly good job. The InVideo plugin doesn't do things on sort of multiple levels of detail, while the Crazy Bump combines multiple granularities, so it can get some of the bigger shapes out of there. But let's look at the ZBrush one. Just look at how much crisper that is. And that normal map was made because that wall was sculpted literally in 3D using actual models of rocks. And let's look at sort of the end results of that, and look at them with a blend, and just look at how much kind of more definition you get with ZBrush. And the importance of getting good depth height maps, and good normals is going to get more and more important, especially with kind of next-gen PC hardware, which is kind of dealing with adaptive tessellation, where the textures you plug into the shader don't just affect the surface quality, they actually affect the geometry itself. So you have to get really good at generating great height maps, and use ZBrush for that. Use its 2.5D, use its 3D sculpting. It's fantastic for that kind of thing. And although I said this would be mostly about environment modeling, I don't want to leave the budding shader artists, texture artists in the room in the dark. And this sort of 5-minute tutorial was created by our lead texture artist, Tate Mosesian. And it started simply as a cube in Maya, or at least a brick-shaped cube. You might have guessed by now that we're going to be making a brick wall. And it turns out, though, that there really aren't that many tools you need to sculpt something like this. ZBrush is not my sort of my area of expertise, so I'm not going to pretend to know exactly what he's doing. But we will just sort of run through this quickly. The idea being, let's try to create a singular brick with as much detail as we can. Now this is kind of almost the opposite approach of what you saw when we were modeling that environment, in that we're starting with the detail here. We're starting with the smallest detail we can possibly start with. And sometimes that's kind of appropriate. Sometimes it's hard to know which way to go about it. Do I start with the big picture and work in the details, or do I start with the details and work out the big picture? It would kind of suck to create a really rough wall and have to paint every single brick of that wall. So let's not do that. And in fact, let's sort of overlay some of our detail patterns onto this and really give it a lot of love and a lot of detail until sort of this singular brick is our hero brick. Just adding some noise just to give it a bit more richness. One thing to watch out for with noise is if you can tell it had noise applied to it, you've failed. And the hawk eyes of our texture artists will spot it immediately if any of you should ever apply at Naughty Dog. It's like, oh, that was generated with a default algorithm of some kind. Avoid it. And notice this is quite subtle. You can barely tell at the end that it was actually that had noise applied to it. That's especially the worst. If all your textures look like they've had a Photoshop filter applied to them, don't do that. Let's get some color on this. One of the most powerful kind of features of ZBrush when it comes to painting on 3D models is that you can actually use the shape of that 3D model in how you apply the color. So in this case, Tate's just dragging out, so only part of the brick is actually going to get caught by that color. So it's actually sort of form dependent, and keep layering this up so that the different heights, different depths catch different amounts of color. And it's very, very important to get that 1-to-1 ratio between color and form, which is quite often so easily overlooked. Like you want your color map to really support the forms rather than just be kind of blanketed and indiscriminate with the forms there. Let's skip a little bit of this, I think. And start placing them down onto a 2.5D canvas. Now, I think 6 bricks were created in total. Might not have needed so many. We could probably have got away with just a couple because you can place them upside down and in so many different ways. This is using the 2.5D, but a lot of our texture artists have started working exclusively in 3D. As in this wall would just be a big 3D model created. As PCs become more powerful, our ability to do that is kind of greatly increased. But there's another really, really important aspect to actually sort of starting with the building blocks, pun intended, I guess, for this kind of thing, is that they can also be turned into 3D models. And put in game, actually rendered 1-to-1. And you'll notice that in Uncharted, there are quite a lot of bricks kind of strewn around the ground. And all of those were rendered from ZBrush models like this that were then used to create the texture. So you have this kind of coherence between the two. You have this actual 3D manifestation of it, and then you have a surface manifestation of it. And you can use them both. So it's incredibly powerful. And I want to give more examples of that in a minute. Let's just finish this. After kind of placing it all down, then it's just a case of exporting the color, normal, and the height map. But I can just jump along a little bit and show you what the color map looks like without any lighting information. I don't think I can find it. But the point being, actually, the color map is fairly simple. It's actually fairly monotone. A lot of the temptation is to kind of put a bunch of lighting into your color map, put a lot of contrast, and make it a piece unto itself. If a color map looks good when you look at it, it doesn't necessarily mean that it's right for the game. In that the normals and the shader and the ambient occlusion and all the other kind of rich layers should support that color map in a major way. It's a temptation to let the color maps dominate. So just try to avoid that. All right, let's get back to our level. Let's bring in this wall. This would be kind of one of those pieces that works very, very modularly, that you can kind of jam it into other things, partly because it's so noisy, and that noise at the edges, in fact, an example of a color map that has a little bit more painted in than perhaps you would normally, helps to hide a lot of the seams. But it does make it a great kind of modular piece. And it's really important that your time get taken into account at every step of the way. Maybe you'll be saying, you know what, that could be slightly better, but it's going to take me a whole week. Maybe you shouldn't do that. Of course, I'm just making fun of some of the pitfalls that we all fall into as kind of obsessive artists who love our work so much. And now let's create this piece of the wall from scratch. I actually have a prototype just like this I could bring in straight away. But I just kind of wanted to make fun of myself and say, well, this is some low-res stuff going on here. Let's skip a little bit further along making that. That is low-res. I don't know if it's quite matching Uncharted quality there. We might have some problems. We're going to have to model in a bunch of detail there and just work at it for a while. No, I don't have enough time. Remember I said I made this entire environment in 3 hours. So let's see if there are some shortcuts we can take to make this look a little bit better. And there's one of our shortcuts. I just brought in a move mod filled with bricks. These ones actually weren't rendered from the high-res ZBrush models. But if you look around Uncharted 2, and especially Uncharted 3, you'll notice that the vast majority of all the details are done with kind of complementary 3D pieces that support some really, really simple geometry. Now, this is incredibly important for your workflow. You really don't want to be spending a lot of time just carving out bricks every time you make a wall. This way, we can bring in a move mod of them, and we can sort of seam it up to the wall. And great, cool. But this does take a bit of investment. Some of our less successful attempts, we've put it together and we've said, whoa, that is obviously done with 2 different pieces. There's no blending there. So we kind of took a little bit of a hit on the noisiness of it. We made it visually noisy in order to kind of make sure that those move mod pieces seamed nicely with the wall. Let's look at a few examples of move mods and the textures they seam up to. This one was actually created from the height map in ZBrush, so it actually works for the texture quite nicely. Quite often will sit on top of that kind of rubble to give it some definition. Here's an example of that being used in game, and you saw it in our level. Here's probably one of the better examples, in that those brick pieces, the tile pieces, were rendered one-to-one in ZBrush, and they were also placed down on a tileable texture. So the way these complement each other is really quite delightful, and really helps speed up the workflow immensely. This is an example of what not to do. Now, it's very easy to get carried away. Let's just keep adding detail and adding detail. Let's not forget how long it's taking us and how expensive it is. Notice all that, like those brick details in the middle of that wall. And some of the silhouette details, they're really barely adding that much to it. Well, if we had a couple of move mod brick pieces that we could just stick around the edges, we'd get the same visual result in about 1,000th of the time. So it's very important to kind of keep an eye out for this. And the way we've been moving, especially in Uncharted 3, is towards this very, very modular approach. Nearly all of our environments are created by these move moddable 3D pieces that are attached and sort of paired up with textures. All right, let's get back to it. Placing this washing machine here. Guess it kind of makes sense. Although I'm going to turn it around because it's not going to look that good facing you. Notice I've been deleting the block mesh as I go. Usually, actually, I'll delete it before I even start on an area. It just happens that I made the block mesh for this, so I'm totally fine with it most of the time. The reason being, as I just want to get a sense for it, and then I want to let kind of the prototypes pieces I have dictate what ends up happening, or sort of the artistic vision. Like ultimately, there's a lot of leeway to the design you get. Just like I said, it's bad to paint on top of block mesh as a concept artist. It's also bad to model on top of design block mesh as an environment modeler. The trick is to kind of extract the essence of the design, the important elements, and then completely wipe the rest out from your mind and create just what's going to look awesome. I'll show you some more examples of that later. Here would be just say, you know, sure, we could make it that blocky. In fact, we could probably go a lot further, and probably should go a lot further, and if time wasn't so much of the essence, we would. Now notice I'm adding kind of cuts here. Topology is kind of a big deal, especially if you're trying to get a job. Proving that you can make good topology is very important. This is not that good topology. Some of you may have guessed. Although it's better than not having put in those cuts at all. The reason I'm putting them in is for lighting, which we'll talk about later. Now let's talk about actually just cuts for lighting in general. Uncharted's engine is primarily vertex-based lighting, although we've been moving towards light maps closer and closer. And in examples like this, you see some pretty weird kind of cuts underneath there. They are to support the vertex-based lighting and avoid kind of buried verts that end up going black, which is a problem, kind of an inherent problem with vertex-based lighting in general. And sometimes we add topology for it. All right, let's bring in some more move-modded pieces of wood to support this this kind of floor that we're making. Notice that most of the wood ends up inside the lip of the floor. And this is just to keep in mind that it needs to be pliable. So the actual surface that Drake should grab onto has to be at least fairly simple. And this is kind of a trick to get a lot of silhouette and interesting detail without necessarily making it a nightmare to play. Notice a few of the wood pieces do jut out, but they're actually kind of helping with the ease of interaction rather than hurting it. Notice that I actually just grabbed that wood shader and applied it straight to the top of the model. It's very important, I think, to kind of use the level as a palette for shaders, in the sense that what's in there, if you can use something that already exists in there, you're going to end up saving a lot. If you just keep adding new shaders and new shaders, you very might well find that you're out of memory, or out of worse things. Time, I guess. You need to go to the bathroom or something, maybe? Out of something important. Let's move on a little bit. Apply some concrete to that. Add a little bit more, add a few more wood pieces underneath. Just trying to create, I guess, a rich floor here. This isn't very true to life. There have been floors created in Warzone included that are kind of made from actual kind of architectural schematics just for the realism element. But ultimately, if it kind of feels okay, if it feels right, and it's going to fit into the scene, just given how kind of organic and broken everything is, it usually kind of works. Let's reuse that top piece for the bottom one and give it a little bit more interest to it. Awesome. Let's talk about texture memory, actually, while we're talking about reusing shaders in the scene. Something to keep in mind, and it really seems so obvious, but it's really easy to forget, that a 512 by 512 is 4 times smaller than a 1024 by 1024. And the same goes. So actually, there are 32 512 by 512s, sorry, 16 512 by 512s in a 2048 by 2048. 16 times the memory. And it's kind of a newbie mistake to just not realize that you're exponentially growing, maybe exponentially isn't the right word, but not just linearly growing the number of textures used. So just keep that in mind. Some maps don't need to be the same resolution. Quite often spec masks or some other elements can be lower. Use tiling textures, we use them everywhere in Uncharted, and we also paint blends to kind of get away with that tiling, to hide some of it. I'll show you that later. Use detail maps so that you don't have to make them quite as high resolution, although they are, I think, becoming less popular, that's for sure. We also use individual channels of a color map for the spec or some of the other grayscale maps. Believe it or not, there's also a spare channel in the Z component of a normal map. You can add textures to that too, grayscales to it, we do that. And we also combine grayscales together because the PS3 compression works best when you've got 3 channels. These are an example of blend shaders. In fact, most of what you've been seeing is an example of blend shaders. And notice kind of the rubble at the edge is kind of blending to that different, and it's hiding a lot of the repetition of the textures. Here's another example of a diffuse color shader. So this is all using the same texture maps, but they're all different colors because it's done in the shader rather than in the texture. Let's look in game actually. Uncharted uses something called texture streaming, which you've probably witnessed actually as you play games, and Unreal uses it too if you've played Unreal. I just turned our available texture memory down majorly so you could see it happening. The idea being, if it's on screen, it tries to load it in dynamically, which essentially means you can have unlimited texture budget as long as it has enough time to get it on screen before you see it or get too close to it. Although you still have to be quite careful. Alright, let's get back to our level. This is it's good to have kind of standards, I suppose, for sort of floor heights. We have a standard cover height. We have a lot of kind of rough standards, but at the same time, it's good not to get too carried away. The temptation is to kind of fit everything together in a really intricate way, in which you just nudge one thing and suddenly it creates holes in the level, or they don't seam up the way they should. I like to kind of create loose standards that allow a lot of kind of jamming together of pieces. The more you can jam a piece together, the more kind of flexibility you have, and the more often you can reuse it. So some of these pieces are particularly helpful. Like, notice that those stairs were actually a bit bigger than this floor height, but it didn't really matter because I could just jam them through the ground. Still, it's funny, in all this modeling, I've really only used 3 or 4 different commands. It's pretty much extrude, edge cut, and move. It's amazing just how much you can do with kind of the primitive commands. In fact, in theory, you could create any model if you had enough time, using just 2, which would be kind of amazing. But kind of keep that in mind. A lot of people are like, oh, I don't know how to make this because I don't know the tools. Sure, try to find a good tool way to do it, but sometimes you just have to kind of get dirty and start manipulating individual polygons. Let's get some topology on that. And notice I've been kind of applying a lot of UVs to stuff and shaders. Normally the shader artist would do this, although a lot of background artists like to at least have an idea of what's going to be on there. And I've also been scaling the UVs very kind of roughly, not to an exact scale, and quite often we kind of eyeball it most of the time. But that doesn't mean we shouldn't talk about pixel density and MIP maps. Something that very few people seem to kind of grasp the importance of. And my apologies for getting all technical on a lot of this, but it is my field, and it is one of those kind of pet peeves where I'm all like, oh, why don't you understand that? You. So MIP maps, any texture you see being displayed in a 3D environment, or at least the vast majority of them, before they get displayed to screen, have been processed to have MIP maps. And that's actually just smaller versions of that texture. And these smaller versions of the texture are really important when they're being sampled to display on screen. If you don't have the smaller versions, everything gets really, really noisy. Even though it's kind of memory intensive to add these. It's kind of necessary for all the current gen hardware to display them properly. We should keep them in mind, though, when deciding what texture resolutions to use. A huge problem, well, not a huge problem, but one of my pet peeves is kind of the opposite of a huge problem, is when people think that adding more texture memory, sort of making textures bigger, is going to make it look sharper. It's like, why is this so blurry? Let's bump the resolution. Actually, quite often, that's not the solution. In fact, I'll show you, it might even be the opposite in a minute. As an example, on the right, we have 512 by 512 applied to 2 meters, and on the left is a 1024 applied to 2 meters. And they look almost identical, and that's because of our screen resolution. And on Charted, it renders at 720p, which is 720 pixels by 1280, which means if you've got a 512 taking up that amount of the screen, it is using every one of its pixels. It's like 1-to-1 pixel to screen ratio, which means it cannot possibly get any higher resolution than that, really, effectively at least. Under these ideal circumstances, of course, at angles and stuff, you're talking a different scenario, and there are different types of sampling, some of which cost quite a lot. And actually what's really weird about these shots is that at the top right, the one that looks the sharpest is actually the lowest resolution. It's a 512 by 3 meters. That's really exciting, isn't it? That's just how exciting pixel density is. Now I'm beginning to regret saying that we play God. But yeah, this is important to keep in mind. Not important to keep in mind as the ceiling falls on your head. Not that important. All right, let's keep making our level. Now it's funny that this was made in 3 hours. Just to give you kind of a reference for how long an area like this would take. Typically, I would assign about probably a month, maybe a little bit more, for an area this size at the beginning of development. Probably more like 6 weeks. This would be kind of, I guess, a vignette representation of a bigger picture. But at the end of production, that same kind of six weeks of work, because all these pieces already exist, and like I was saying, this is more like the end of production, would probably be done in maybe a week. Although what tends to happen is at the end of production, everyone has a vast legacy of work to attend to and fix. So we tend to eat a lot into that, which is why we never really have a 3-hour development time on a section of a level, although that would be pretty cool. So I'm bringing in pieces of pre-made kind of walls. Now what's interesting about these pieces is that they were made for a very specific area of the game. It called for this. It was on top of a broken building. And they were made exactly to fit. The windows were all in the right place. But at the end of it, the kind of when you stand back and look at it, you say, hey, you know what? That piece could probably be reused. So they were made modular. And here I am just kind of jamming them together. And it can actually be quite effective. There's a bit of sort of play to this. You've just got to bring your pieces in, see what you've got, and sort of experiment with like what's going to fit best. In fact, I knew that this piece had been made specifically for some stairs in another scenario. It's also a bit bigger, so I brought that in too. But you might be wondering, like, what's past these walls? Like, what are we going to put through all this damage? It's definitely leaving a lot of exposed areas. If I can find my mouse. Skip a little bit. And actually here, originally there was a window that Drake could climb through. And this would be the example of just taking a prototype that already exists and modifying it slightly to work. And the funny thing is, once you've done that, is that then you should make a new prototype, because maybe you'll actually need this part, the one with an exposed window, in the future. So it saved a lot of time just using pieces that already existed, even though we weren't using them exactly. All about reuse. There's another one of our wall pieces that works very well to seam everything together thanks to its noisiness. I'm not sure what's on this one. And sometimes creating kind of hero damage buildings is particularly important. This one also, though, is very, what would be the word, generic. You can probably use it 5, 6, 7, 8 times, and you're not going to see the repetition. Also, part of kind of choosing what to put in these modular pieces is avoiding too much detail, because a lot of the detail can come from overlaying pieces, sort of plants on top of walls or wires on top of walls, and that can all kind of tie in. Every time you place it, you can put something different on it, and it doesn't really take that much to make something look very different than what it did to begin with. Skip through that. It's also good to have a variety of pieces. Quite often what I see happening with sort of new recruits, people without much experience, is that when they're creating a prototype set, like say creating these buildings, although usually we're creating things for a very specific environment, so we're making the buildings to work exactly where we want them to, and then reusing them later on. If you're kind of approaching it with that generic, let's make a set mentality, quite often every piece is far too similar to the last. People will make new pieces and then modify them slightly and save it up as a new one. Ultimately, you want as much variety and sort of change as possible. Like the building I just placed was a lot thinner and a lot taller than the other buildings, and you need that kind of variety in order to kind of use them in all these different circumstances. Let's talk a little bit more about what's beyond that ruined wall. Perhaps it would be a wide. In fact, that's kind of the word we use for them, wides, because they do require quite a different kind of construction mentality. This is the Shambhalan reveal, and it was, I think it was worked on for maybe 2 months by a single artist, and let's just kind of go a little bit in depth with it. Actually, we'll go in depth with Warzone. Wireframe view, as you can see, the wireframe density is fairly even. It's because the wide was made for really just a few shots. You're not going to have to get too close to any parts, so there's a pretty consistent amount of geometry across it. Let's look at Warzone's wide, one that took a lot longer because we kind of set out to define a few paradigms and make this sort of something that we hadn't done before. So this was actually the first wide we did of its kind of epicness, and it was one artist for a lot longer. One of the reviews that I read mentioned before they'd actually got to play the game that the building, the wide looked like you could go to any building in the wide, which I took as quite a compliment, because that's kind of the idea. You want to make it feel like the world extends all the way into the distance. Excuse me. Let's look at that wide in Maya. Of course, it isn't made to the same resolution as everything else. We very specifically know that it's going to be seen from sort of a general area, and we build out sort of getting lower and lower res the further back you get from that location. So there's a foreground set of buildings, there's a mid-ground set of buildings, and there's a background set of buildings. Although that sometimes just depends on what your constraints are. Notice that a lot of that geometry isn't even seamed up properly. It doesn't have good topology. It's because we couldn't afford it, nor would we want to. And let's take a look at that texture, actually. That was a rendering of high-res buildings. Now, here's one of those things where you want to start, again, with the kind of the high-res. It's nearly always the approach these days, is like make it in full first, and then you can gradually bake things down to a lower version. And that was just a rendering with ambient occlusion stuff baked in to create these very, very low-res buildings. These ones right at the back, notice that they're actually segmented. They are made to be seen just from one view, so they don't have backs, basically. The model still exists there to light the level properly, but in-game it doesn't show up at all, which is very efficient. Let's have a look at another wide. This one was made as a reveal for coming out of the tunnel. We wanted to give the player a bit of a treat, having been in the tunnel for so long. Yeah. So what's interesting about this wide is that it was made in maybe 2 hours, very near the end of production, because we were out of time. But that didn't mean we couldn't ship it at Naughty Dog quality. It just means we have to get a little bit fancier with it. And what we ended up using actually was a piece of concept art. Now you'll actually see this in a lot of games. They deliberately use what we'd call a map painting in the background for any kind of contained view, and it's literally just a picture. And why shouldn't it be just a picture? Because after all, they're just pixels on the screen. Let's take a look at that wide. It's a little bit more advanced than a picture, I'll admit. Sorry. There we go. So it's actually the wide projected onto some models to give us some depth. And notice that it's really skewed and it looks horrible and doesn't look right at all, but it was projected from the exact view of the camera as you come out of that tunnel. So it's actually held up very, very well. And that kind of hybrid map painting is, I think, has become very, very popular over the last couple of months. Well, not months, years. Although I have a feeling it might become less popular as 3D becomes more popular. We'll see. Oh! Come on, guys, you know what to do. Just hands up if anyone knows the answer. Wow, are these too hard? I'm sorry, I didn't mean to make them too hard. Oh, guy at the right. It is too many something. It's not polygons. That's getting close. That alleviates overdraw. That is something that helps, but it's not the primary kind of alleviation. No one? There's a mug and a T-shirt at stake. The gentleman at the front. I mean, in the middle. With the red. No, it actually doesn't have anything to do with texture maps. The guy behind him. Too many draw calls, not that either. It has something to do with pixels. Only gentleman with his hand up. I'm sorry? And now we're just throwing out terms. A joke at Naughty Dog is that some people, when they're just trying to sound fancy, will throw out terms like that. The favorite is poly contrast. What is that? It's just a made-up thing. Let's up the poly contrast on that. What? So the actual answer, though, and I'm glad that no one knew, because I get to keep the Naughty Dog mug and the T-shirt now. And also, it confirms my suspicions that no one pays attention to overdraw and what it means. First, let's show you an example of what someone might unwittingly do without understanding overdraw. So, these very helpful kind of rubble pieces that I've been using all the way up to this point, that I've just been placing right on top of geometry that already exists. It is actually pretty bad for overdraw, and I'll explain a little bit more what overdraw is, but it's basically pixels getting drawn on top of pixels. When a scene's rendered to the screen, You render a polygon, and sometimes you have to render a polygon in front of that. And it ends up doubling up pixels, tripling up pixels, quadrupling. Sometimes you can render thousands of pixels onto the same pixel on screen, and that is a very big waste of rendering power. And what's kind of interesting about that Rubble Move mod is it sucks for overdraw. Everywhere it is, there's 2 layers of the ground. And depending on kind of how well it gets culled out, the answer to that previous question, by the way, was the depth buffer that gets drawn helps alleviate overdraw majorly, because it doesn't draw, at least to some extent, it culls out pixels behind the depth buffer. Most modern engines render the scene to a kind of a height map first, so that they know if like these expensive pixels actually need to be drawn or not. A little bit more about that later. Overdraw. Here is an example of something that will chug the Naughty Dog engine. And we have a good engine, we do. But take 10 layers of polygons and put them over the top of each other, and the engine will screech to a halt because it is drawing pixels on this screen again and again and again and again because they're not getting culled properly. In this case, they're also all the same shader, so they don't get sorted properly either. What's even worse than that is transparency overdraw. Transparent pixels don't get culled at all by the depth buffer and end up costing even more. So this is running at like 2 frames a second. Who would have thought it was so easy to bring Naughty Dog's engine to its knees? Let's look at the game I'm sure we're looking at right now. Oh yeah, we are looking at fade distances. Now I'm adjusting the fade distance of anything as a fade distance in real time. Early on it was discovered that it's really easy to cut down on the amount you're drawing when things just disappear. So at a point, a lot of the scene, anything that's blue right there, will disappear when you get far enough away from it. Some things, if you look really carefully into the background, you'll see some things fading out. The performance kind of implications of this are quite positive. And ultimately, when you're playing, you really don't, it's not that much of a detriment to the experience. I'm sure as sort of budding game artists, you've studied the hell out of this kind of thing, and you'll have caught all sorts of kind of LOD errors and seen things pop and seen things fade in and be like, I see it. Oh, yes, you do see it, but if you were actually playing, you probably wouldn't care. So it's kind of more important that it runs in frame rate. Quite often the biggest mistake is to keep saying, well, there's a detrimental look to this optimization I did. It made it look slightly worse. And to forget that a smooth play experience is very important. So let's actually talk briefly, just as kind of an insight into one of our major performance factors at Naughty Dog. And it has a lot to do with the engine that we use, and the way it kind of way it renders things. We call it a vertex set, which is an optimal number of vertices used, rendered at any one time for any one piece. Around 300 verts is an optimal number. If you have too few in a prototype, it's kind of a shame. You're just wasting verts. You could have more in there, and you get the same amount of bang for it. If you have like a little bit more, you might end up with 2 vertex sets in that prototype, and that is also inefficient. A little bit more on that later, but I just wanted to give you that kind of heads up. Down the bottom right, that big number is the number of vertex sets being drawn on screen. And that's sort of the number being processed, and that's a pretty important number because when it kind of gets too high, we're almost guaranteed to chug. We don't look so much at polygons and individual verts as we do those kind of chunks of processed vertices. And now if we look in wireframe, you'll notice that every step of the way, we're drawing a little bit more as we look around this corner. This is because it's our visibility system. It's actually a pre-computed visibility system in that it's stored before you even start playing the game. It knows what's visible and not visible around this corner, which is the reason some things popped in a little bit too early, in that there's only so much granularity you can put in a pre-computed visibility system. This works quite differently from some other games, especially real-time occlusion systems, but it is very effective for the most part. Sorry about that. let's get back to our model. I'm going to apply some shaders, and this actually I'm going to do one of those kind of hacky techniques that there probably should be a better way to do it. In fact, if any of you see any better ways to do things, please come talk to me. Because every time I see someone else's workflow, I'm like, oh, you should be doing this, you should be doing that, and the same applies in reverse, in that we all kind of discover different tricks and techniques that are definitely worth sharing. This one was kind of a hack in that you unitize all the UVs, so they're all one-to-one. One face equals sort of one UV space, and then you wield all the UVs, and that allows for good kind of UV flow around corners. So to see that those bricks at the top of the road curve along with the road itself. I'm also using a lot of edge loops again here. But I'm also doing it kind of messily, I'll admit. And sometimes time frames, they kind of call for a little bit of messiness. And it's all about kind of, well, what's available to you, and how do you make it adequately awesome in as little time as possible. Which kind of brings on to something else. Something very important. Whoever... oh, crap. Sorry, I'm getting overlaid videos right here. Okay, there we go. Okay, my apologies. All right. Everyone take this seriously. The player's wearing white specifically. To get a lot of attention. All that laughing was giving it away. Some of you may even have seen this before, because if you fall for it, it's delightful. But what it kind of demonstrates, though, selective attention is quite relevant for game design. You really want to be making the environment in a way that's going to acknowledge what the player is paying attention to. As kind of an example closer to home, at Naughty Dog, a lot of us are big fans of Star Wars. And during the creation of the chase sequence, we actually put in a real live Wampa, just sitting in the tunnel. And during one of the art reviews, when a lot of the company were looking at the level, we were running through it, and me and one of the other artists involved with the level were sitting in our seat, all excited. You know, they're going to see the Wampa. It's going to be really great. Yay, Star Wars reference. And not a single person saw it. And it was right next to the truck. And why is this? Because the truck was blowing up some dudes at the time. They were all looking at that explosion up in the distance. And a lot of the environments we make are kind of based on the principle that the player is not looking at them a lot of the time. Which means you kind of want to pick your moments. You want to pick those times where, you know what, let's put in a Wampa here because the player is going to see it. We didn't ship with it, of course, but it was still an interesting experiment. So, if you're making a rock for your scene, make it the best, most awesome, interesting, detailed, and high-fidelity rock you can possibly make it. Well, no. That's kind of tunnel vision. That's when you get so kind of into any one detail that you forget the overall vision, the overall product, and the overall experience you're trying to convey. It happens to us all, myself included, on a regular basis, where I'll be so fixated on some detail, I forget that, you know what, in the big scheme of things, this is very unimportant. An overall scene reads, kind of the impression that players get is far, far more important. And that also goes to like where you should kind of put the most amount of work. Let's sort of emphasize variety that players pick up is really important. Immersion, if something breaks you out of the experience, that's important, but it's very easy to forget just how much it takes for something to break you out of the experience too. Emphasizing the story and things that the player actually sees. Readability is incredibly important. We'll get into that a little bit more. Aesthetics, of course. De-emphasize, though, the individual quality of any one piece. Generally, players aren't going to go up to those pieces like you do and examine the hell out of them. They are not artists. They're in it for the experience, and they do not have time. Detail also is just kind of this umbrella term that people use to describe something that's cool, and not like, oh, it's so much detail. And detail is great. It's awesome. But rest for the eyes, areas of calm are also very important on top of detail. So it's less about detail and more about kind of contrast between high detail areas and low detail areas. Of course, we want a really rich environment. It's just full of all sorts of things. We want to throw everything into that kitchen sink. But it doesn't necessarily mean that you have to go kind of overboard on it. You can hurt a level with too much detail. And then de-emphasize reality. Ultimately, we want to create amazing experiences for people. And that's never really been done by using sort of reality to a T. Everything's embellished upon in at least some way. Another kind of thing, just to take away from all this, task players aren't looking at your environment. If you've got an area and there's this huge explosion from this tank and Godzilla and Furby, and all sorts of things. That cat with a toaster on it, is that Nyan cat? Yeah, that thing too. If that's all happening, you probably shouldn't spend that much time on the environment in that area. It's not... sure, you could, and you want it to be awesome, but hey, you know what? Maybe you should wait till that player's kind of at the top of a building doing nothing to spend all your time on the environment up there. So downtime and first impressions count more than anything else. It's like when the player is just walking between places and they're just soaking in the new area, that is when they're going to kind of experience it and they're going to appreciate it. It's very easy to get sidetracked and forget that like where you're putting your effort matters. And I would say it's better to blow the player away with amazing environments now and again than maintain a consistently okay look. They both might take the same amount of work, but you're going to get way, way more bang for your buck doing an amazing one now and again, even if you have to sacrifice quality in some areas. This, I realized, just helps to confuse things. So I'm not going to go too far into it, but the idea being don't invest the same amount of time in everything. Make sure that downtime and introductions of new looks and cutscenes kind of get the most attention, because that's when things can be scrutinized the most. Oops. All right, let's get back and let's start painting some blends. Now, I kind of consider this the move mod of the texture world. And it lets you get a lot of kind of, what would be the word, one-to-one coherence between a shader and what it's on. And now notice I'm just painting these blend values sort of around that rubble so that it integrates nicely with it. I'm very poorly painting them on top of the side of that curb. They probably shouldn't be painted there. That doesn't make any sense that this shingle going wrapped all the way around there. But ultimately, this is very, very powerful. So let's talk a little bit about those and their ability to sort of, for every model, create a different kind of shader look. So the way they work is two kind of sets of textures getting blended together based on a threshold. And here's sort of a very, very, very simple shader in Surfer. Notice how the F blend map shows through on how the transition from this green to this gray happens. So you can see it kind of the shape of the F holds its ground between the two, between the transition. And let's look at a sort of a more realistic version. On the left, you've got the vertex colors. So this is just one polygon painted with white and dark at the top. On the right, you've got the kind of the final blend value. If it's black, it's coming from one texture, in this case the brick. If it's white, it's coming from the mortar, kind of the dirt. And let's actually up the blend value. Check out the way that the dirt kind of creeps up the rock. And the reason this is so awesome is because that threshold texture is actually the height map. So the dirt actually kind of creeps up from between the cracks of the rock and kind of fills it out in a very realistic way. So when you paint this, When you paint on that dirt, it's not just transitioning smoothly between them, it's actually obeying the actual depth of the bricks in a realistic way. This is actually a shader network in Maya that reproduces the blend shader. It's a little bit cumbersome, but for those who are a little bit more technical, this will just give you an idea of kind of what the blend shader is doing under the hood. Let's look at something derived from the blend shader, which is always a bit of a crowd pleaser. It's something we call the slope shader. It paints blend values not using vertex colors, but using the world normals of the object. So anywhere on the top in this case, you've got snow. No matter what you do to the model, you're always going to have snow on the top. Now you apply this principle in quite a few other ways. As an example, if you know where there's a water line, you can create a model with a shader on it that whenever it's at that water line will have the kind of the wetness go all the way up to the water line and then stop at some point. No matter where you put that model, it'll always kind of obey that line. There's a few other ways to do this. Just kind of imaginative painting of values based on some of the data we have available in the shader. Let's look at one of the scenes with that snowy blend slopes shader in it, and then move on. This is actually one of my favorite topics. Alright, let's kind of finish off a few of the buildings that we're putting in. Let's give it a little bit of a slant. Notice that I've rotated nearly everything I've put in. I don't want everything to be at exact right angles. It's good to give it a little bit more character. Let's also block this window up because it's going straight to a wall and doesn't actually make any sense at all. Sometimes the trick is to hide the flaws rather than fix them, whichever is fastest. Although too much of that and I won't be happy because it's expensive. In fact, in this case, we could probably just hide that window behind it and it would be fine. This is actually an interesting prototype and move modded that's made for a very specific case. Those book pieces actually have a proper book silhouette on them, but only work when they're up against walls. So they got a little bit of transparency to give them that kind of interesting book silhouette. This is all a little bit unrealistic at this point. I'd expect this exposed to the weather. These bookshelves and books would be much, much gooier and kind of more washed out. But that kind of goes for any of the stories. Sometimes it's better to tell a story that's, it's something than not to have that there at all. It's still more interesting. Other times it's just, okay, let's not do that. So instead of fixing those books, which will take kind of a while at this point, I'm just going to cover them with plants. Plants. Is there anything they won't cover? And now I love plants, just in nature and in video games, just for their challenges more than anything else. Like how do you recreate something that's so detailed and has so much depth to it and life to it in a video game? And move mods have helped us to some extent this generation to giving us the ability to kind of flow things over each other. And notice I brought it in as one piece, one ref node, and there's already a kind of a good flow to it. And it was made that way to begin with. But let's modify each piece and get it to wrap around this building in a really kind of cool, kind of hugging kind of way. And you'll notice that the majority of plants in Uncharted are made in a similar way to this, in that we get this kind of this one-to-one coherence between the plant and whatever they're on, without paying a lot for it. It's actually just, so far we've only used two prototypes, and the engine will treat them just as two pieces to render. So it's really not that bad. Plants are also particularly difficult for the overdraw. As I kind of demonstrated earlier, it's really easy to bring even our engine to a crawl. So I want to just sort of talk about how to kind of make them. Notice that Drake's eyeing that plant. He also likes plants. So this is that grass we saw earlier. Over to the right is just kind of the texture map. There's no geometry on that. and to the left was the actual geometry. Here's a kind of a wireframe view of it. And there's like a close-up on just a couple of the stalks. And there's something interesting about that formation alone, is that all of the silhouette detail attempts to come from the transparency map. And that's the trick with plants. You've got too much detail to do with geometry, that you really have to do it with nothing but the transparency. And let's look at a few other examples of that. There it is in practice again. That's the one we saw earlier that was wrapping around the buildings. That at the top right is just the texture used for it. And there's another example of it in game. This time it's being used to stop that edge looking readable. There's another plant used in game. What else have we got? Aha. Here's an interesting level. In Uncharted 2, the kind of the bamboo forest train ride, that was a lot of plants. And I want to take you through making just one of them. Like how really did we get that level working with such a problem with overdraw? We had a lot of overdraw in that level, and like I showed earlier, it chugs when you have that much. So let's start with a leaf in this case. Just a single leaf. We're starting with the details again, and let's turn that leaf into a small branch. And let's turn that small branch into a bigger branch, or collection and clump of branches. I mean, you see all this. Imagine trying to make each one of those leaves individually. It is going to take a while. Don't do that. Instead, start with that small detail, modify, make a couple of varieties of it, and just start duplicating. And it's funny that nature has a very tree-like structure to it. Often branches branch into branches, which branch into branches. You can make the smaller branches and then kind of make the bigger branches out of them, or to some extent vice versa. But when making a tree, don't start with the trunk and then start working down to the leaves. Start with the leaves. And this is those set of leaves rendered from the top. Notice that in that set previously, I had... I'm getting a bit ahead of myself. Let me just pause this. In the set previously, I had a couple of, like this piece and this piece, exactly the same piece. And they're actually offset in exactly the right amount so that when I render this from the top, it tiles. So this is the rendering. This is actually a slightly modified rendering to provide for less overdraw. It was one of those things where we rendered it down, we put it in game, and we were like, crap, there's too much transparency there. We can get away with less. And then notice how it tiles nicely. And that was also rendering the transparency map, which is kind of what we get all our bang for our buck from. We had a normal map and a color map. We didn't end up using the normal map. We just weren't getting enough bang for it. Here's an example of that texture put into practice. But let's actually first make just one leaf. After you kind of have this polygon with your transparency applied to it, it's time to start cutting it out. A lot of people kind of make the model and then try to make the transparency to it. Actually, I found that works the other way far, far better. So if you make the transparency map, you make the texture, and then you cut out based on it. It also lets you very, very closely follow the transparency because you want as little transparency as possible because of the overdraw problems. So here I am cutting just down the seam of the bamboo. A big mistake here is that people add a lot of detail. As in, like, they'll smooth this out. They'll add lots of subdivisions. And I'm gonna make it kind of rough. This is gonna be like, there's gonna be some sharp edges involved here. And I'll show you why in a second. So notice how rough that is. Again, it's like, whoa, gee, that's not Naughty Dog quality there. But it kind of has to be, and that you don't want to add a lot of subdivisions and start creating this kind of curved silhouette that isn't from the transparency map. That's very unnatural. So if we actually look at this piece in the context of this bigger one, let's find a similar piece. There we go. What I've actually done there is added complementary pieces to hide its silhouette. So once again, all the silhouette detail is coming from the transparency map and not the actual geometry. And look, when I take those away, you see that horrible kind of blocky hard edge, which we really don't want. So with just a few extra polygons, you can hide all the silhouette coming from the model. And that's a very important thing to do in transparency. A very common mistake is to just keep adding layers and layers in the hope that somehow tons of polygons will save you from being able to see all the silhouettes. But that's not the key. You've got to very, very carefully engineer the silhouettes of transparency. And actually, I took those pieces and I rendered them to even bigger bushes, and then I rendered those to even bigger pieces of bamboo, and then I rendered that to a looping piece of bamboo that I could enclose the train section in. That kind of provides this very kind of layered approach that is very efficient for the most part, because very, very few layers in, you're talking about something that's much, much cheaper than those initial high-res pieces. All right. Notice that I brought in a bookcase, and on top of that bookcase was kind of an edgy-looking edge. You could always guess that Drake could climb on it. Now, I don't want people to, not be able to play this tiny little piece of the level I made, because it's going to be so fun. So I'm going to cover it in plants. You may have noticed, actually, in Uncharted, there were some plants along edges in a lot of places, and that's because we didn't want you jumping onto them. This all sort of brings up this idea of readability. There are lots of elements of readability that are incredibly important. Like, you want the player to be able to tell where the floor and the wall ends. I know that may be a simple kind of concept, and but it's sometimes easy to kind of lose track. Sometimes we'll find ourselves putting the same kind of tone on the floor, the same frequency as we do the wall, and suddenly they all blend together. And subconsciously, you just can't quite tell how that level is formed, if that's the case. So let's talk about readability, and I want to start with a terrible example of readability. Or at least the worst case scenario, which is a level that's incredibly detailed, that's just brimming over with life. Everything looks like you can interact with it, but you can only interact with one thing. In this case, and those who have played it, I wonder who... did anyone find this part frustrating, by the way? Ah, there we go, see, some hands. You don't get any mugs for that. This was a tricky one. Ultimately, I think we probably should have just redesigned this entire path to be a bit more leading. But we did end up just making that top of that phone booth that you can climb on a different color, and hoping, fingers crossed, that people found it. It wasn't great. It could have been better. Just really because of its noise. Here's another example of just lighting helping readability a lot. Everything kind of blends in on the right. Pops out on the left. Uncharted 3, for those who play it, we've tried to be a lot more consistent with the readability and iconic, in a hope to avoid some of the kind of the more garishness things, which we didn't manage to avoid entirely. And my apologies for stuff that's garish, but we did try to be a lot more iconic to avoid yellow tops of phone boxes. Let's look at this as an example, actually. This is a good one, just because you can see a repeating shape going up into the distance. And of course, stairs also scream that you can climb on them. But that same kind of frequency apart gives you a lot of depth perception and kind of leads your eye along those. And then the same goes here. Notice that the water isn't interrupted at any point during that whole path. So this is the view you get coming into it. You can see it kind of going all the way to the distance. We could very easily have brought some of those roots in a little bit more and interrupted the path and made it a lot less obvious. What's this? Sorry. There we go. Let's just add a few final touches to our environment. Now, one thing that's very often overlooked are details that are above the player's head. It's very easy to kind of create this open space and forget that adding a few parallaxing pieces above the head can make it a lot more interesting. And you can also create a lot of interesting flow up there because you're not bound by the constraints of where the player goes. So one thing we found in the Nepalese war zone look to be very helpful were the wires and kind of that traipsed all over the city. And in this case, I'm just going to set up this this telegraph pole to work for wires nicely. Skip a little bit. Here's sort of one move mod set of wires. My biggest regret with these is that the pivot point was in the wrong space. I'll always regret that. Because it takes a lot of time to kind of attach them up. It's funny, the whole discussion of wires, it's like, oh, do we need a procedural system? Do we need some kind of rope wire physics? Do we need some kind of tool for making them? And it turned out that just a couple of meshes shaped in a curvy wire let you at least have enough flexibility to tie up most of them together. Notice though that when I brought those wires in, they were different colors. They were red, green, blue, and probably pink or something. That is because they are using vertex wind to give them a little bit more kind of, wind. And if you look at those plants that Drake just came by and the wires above his head, you'll notice that they're all kind of blowing in the wind. Those are that exact same prototype that we just used. Vertex wind is actually a very simple system. That wasn't an earthquake. I'm almost a little disappointed. Vertex wind in our engine, it was just kind of like, how do we get movement to these plants in this sort of as effective and simpler way as possible? And the end result was just kind of a world noise applied to the vertex shader and painted based on colors. All the colors represent are different offsets in time. They don't represent an axis or anything. One of the best ways we found to get a nice smooth result for that was using Meyer's transfer attributes to get like nice gradients between different colors. Let's kind of finish this one up. Now, a lot of those wires were actually placed to make the view kind of awesome from where you come into this area. One thing I forgot to mention at the beginning of the video is that knowing like how you approach the level is really important. Like that's the view that you kind of want to spend the most time composing, rather than kind of looking at it from. Sure, the player looks at it from all angles, but ultimately when they're approaching the level, they're looking at it like intensely. They want to figure this out. They want to know where they can go, what they can do in the level. So that's where you should really compose your scene for, despite the fact that, of course, video games are dynamic and the player can do whatever they want. Something else I was going to talk about as I was placing those sort of light fixtures is optimization, just in general, and how some people tend to make very, very high-res pieces for where the player is, and sort of gradually taper off from those high-res ones to lower-res ones. But ultimately, the trick is to try to make everything as low-res as possible, because it ultimately affords you more environment on screen and more richness at any one location. Like your ability to layer these pieces on top of each other is far more powerful than the bevel on any one single piece. As an interesting example, though, let's talk about Drake. He needs to look awesome, of course, because he's on screen the whole time. Although the more he's on screen, because he spends the whole game on screen, the more he should probably be optimized. And there's always that kind of argument, oh, well, he has to look good, he's on screen the whole time. Yes, but the more bang for your buck you're going to get by optimizing him. And optimization can happen without much of a visual hit. It just takes a long time. Sometimes it can happen with a huge visual hit, and it's totally worth it in other circumstances. Of course, it wouldn't be with Drake. And we kind of use that approach for environments too. If a piece is used on screen a lot, then we want to give it the most attention. And if it's not used very much, then, I mean, some pieces we don't ever touch, and they might be terribly optimized, just because ultimately it's not going to get as much bang for our buck. A big mistake, though, is to say, I'll optimize afterwards, after I finished it. We'll finish it first, then we'll optimize it. But when you know the hardware, when the hardware gets to a point where it's kind of settled and your engine's fairly settled, there's only so much you can get out of it. So you have to optimize things as you go, but you will also have to optimize at the end, especially if you're trying to push limits. This is probably the most boring slide. Just some numbers. Put them there to bore you all? No, of course not. Well, it'll have the inadvertent effect of doing that. This is a spreadsheet of all Warzone's prototypes, and the number of vertex sets that are in them, and sort of the numbers used. Quite often, though, when it comes to optimizing an area, order everything by the number of instances times sort of the cost of it, which in this case would be the number of vertex sets, and start there, start optimizing those ones. So for instance, those brick prototypes that I placed were used thousands of times, and as a result, they were very optimized. Another thing to keep in mind, which is an easily overlooked aspect, is that silhouette is everything in lots of ways. Notice that the two pots have exactly the same look below. You can probably barely tell the difference. Yet one pot is like double the polygon count. That is because all those polygons are not going to helping with the silhouette at all. So especially like in art tests and when you want to get the most bang for your buck from your polygons, think about silhouette. As an example, these kind of wire things, although you might say, oh, well, they're round, they should be round. Well, probably shouldn't make them round, just given how many there are, and given that the normals end up smoothing it out to look round anyway. They are all kind of triangular cylinders. And we do that a lot. In fact, triangular cylinders like are pretty much everywhere for any thin piece you see. Here is my favorite example of what not to do again. All that polygon detail in the center almost does nothing. Sure, it has a little richness if you zoom the camera in a bit, but ultimately you are paying a lot for very, very little. And the actual silhouette you get is kind of minor. Like you have all this detail here, but what you end up reading is kind of not that great. Like that could be a lot better with far, far fewer polygons. Whoa! I wish an earthquake had happened at exact that point. That would be fantastic. Now I've realized that these are all too technical. They're kind of like sort of what a technical artist dreams of, not actually practical questions. But if someone has an idea, and I'll actually say, let's just name one of the problems with the cube. I don't even want to go for two. And the guy in the green shirt. I'm not going to give you that, but you might be able to like pry a T-shirt off of me at the end. Guy in the I love San Francisco blue love heart shot. Double-sided actually doesn't increase the number of vertices. It keeps them the same. So like double-sided transparency will be rendering the same number of vertices as single-sided. Guy in the green shirt behind him. Hardened edges, yes! Well played, sir. Well played. Hardened edges end up splitting verts. The equivalent of pulling polygons apart. Most modern hardware, in fact, basically all of it right now, doesn't store multiple normals per vert. So as soon as you have different normals on a different face, then that needs to split. And actually there are lots of other possible answers to this. One of which, actually let's just look at this, I guess, on a very, very simple level. Here we have 6 vertices and 2 faces. They're smoothed, so they're not being split with hard edges. And their UVs are continuous. 6 vertices is all we've got. But suddenly they jump to 8 vertices. Whoa there, what's that UV split you've got going on? We can't store different UVs per face either. So that in the vast majority of modern engines, that will end up as 8 vertices instead of 6. Now this is a big pet peeve of mine, because it's easily overlooked and can sometimes have a massive impact on the performance here. As an example, at one point we discovered that some of the character faces in Uncharted had all of their UVs split. So it was having sort of 6 times the number of vertices in game that it should have been. As you can tell, I was probably delighted when I heard that, because we could fix it and get so much back. This would be an example of the hard edge splitting the verts, the normals pointing sort of in different ways. Another thing that would cause it is different vertex colors. Basically, you can't store multiples of any information on a vert. Different shaders would have the same effect. And a very, very little known one is looping the UVs back on themselves will actually split the verts if it's normal mapped. It shouldn't do it if it's not normal mapped. So all of these have been the equivalent of that, pulling the polygons apart. So be careful. Don't add extra verts. They will come back to haunt you. Let's continue. We've almost finished, which is cool. This is actually supposed to be a ceiling piece, but I'm just being creative or something. Let's add this light. I like prototypes that can combine together in interesting ways. It's like there could be 10 different lights and 10 different sort of fans, and 10 times 10, the number of combinations. Let's add a little bit behind this. We're not actually going to make a wide this time around, unfortunately, because that would take a while. But let's talk about lighting, since we placed a light. See how I did that segue? Clever, huh? This is actually a program called Rainbow that we made in-house. We usually make the majority of our programs in-house, usually to do very, very specific things in as crude a way as possible, as in as quickly and effectively as possible. At Naughty Dog, we're very, very geared towards making a product rather than making tools. Unlike, say, Epic, which puts out its engine as well, of course. So I'm getting sidetracked. This is the direct sunlight baked into the model. In game, when you're close to it, it's actually real-time sun. We'll talk about that later. The dome lighting, the sky essentially lights the level, even if the sun isn't directly lighting it. There's the sunlight that bounces around after it hits the surface. And the dome plus the indirect, all in Nova, in-game, is a little bit blown out because the HDR doesn't kick in for our debug displays. But when it's on, then everything settles down to a much nicer place. Notice those sharp shadows. That is not baked shadows. They are real-time because they're nice and sharp. On the left actually is an example of baked shadows, and on the right, real-time shadows. And that's also why Drake's shadow moves with him, or exists at all. And when he goes into shadow, his shadow doesn't overlay on others' shadows. Keep an eye out for this in games. If your character has a shadow that then adds to another shadow, and you see two shadows, that's because the other shadows aren't real time. It's most likely anyway. And we also use light maps a lot. We actually have a very simple implementation of light maps, which take the original UVs of whatever you're light mapping and lay them out onto one big atlas map for that light map. The benefit of that is that you don't create split verts by re-UVing them. I've noticed that a lot of people, when they create light map UVs, completely re-UV things and end up sort of doubling the number of split verts because of UVs. We try to avoid that. Let's actually look at that shadow in real time. Now you have to look really carefully at this. Right here, do you see that? Do you see that shadow creeping in? That is the transition between the real-time shadow and the baked shadow. We don't want to draw shadows all the way into the distance, so we transition to a baked one. This is actually how the shadow ends up working, the real-time one. It's actually drawn from the point of view of the sun, like the scene is rendered as a depth image from the point of view of the sun. It's actually rendered 4 times to get the distances. Notice that you can kind of see Drake in each one of those. As a result of like this 4 times rendering, we have to be very careful with our optimization for this. This is actually what's casting shadows. Anything you don't see in the scene isn't casting. Notice that the gun popped in and out as we got away from Drake. It's because when we get far away from the weapons in Uncharted, and keep an eye out for this, you'll notice it from forever now, the shadows will disappear. That car was all black because it is using what we'd call a shadow proxy. We're not rendering it with the actual mesh, we're rendering with a fake mesh just to demonstrate. And actually these buildings, all on this side, the ones that are in shadow, all being rendered, the shadows are all being rendered with this one big mesh. And we actually transitioned entirely to shadow proxies in Uncharted 3. So our multiplayer maps, for instance, which are especially important to optimize, just have one giant, big proxy mesh. Let's look at a kind of a simple example of that. Notice that the legs are much thinner in the shadow proxy, and that's because it's important that the shadow proxy stay completely inside the geometry, otherwise it'll end up casting on itself. We also use different kinds of proxies. Check out these reflections. Chloe, of course, is reflecting, so is Drake. That is not a proxy. But check this out. Check out that wall right there. Slightly offset from this wall. Like, why is that? Why is it not reflecting quite right? And that is because, if it continues, there we go, a big image is reflecting instead with a very, very low-res texture on it. And it's kind of messy, it's kind of rough, it doesn't quite form the whole level properly, but it works, and it's much better than a cube map. And we've also transitioned to mostly nothing but reflection proxies, rendered from what we see in-game. Here's another example of a reflection proxy. This one is used in the ballroom water fight, if anyone can remember that from Uncharted inside the hotel. Let's look at something else. This is something you'd call, this is very Disneyland-esque, if anyone's been to Disneyland. Oops, sorry. Disneyland doesn't disappear like that. Notice those cards. It might be a little hard to see in this video, but this is the high-res. This is the kind of the full-on model. And I'll show you the cards in a second. So this is in Maya. Notice that the only lit pieces in the scene are those cards. It's literally just a texture mapped straight to those cards, but taken from the exact point of view that the player is going to see it. And this would be an example of taking high-res level that you don't want to draw and replacing it with basically nothing. Very, very effective from a lot of standpoints. And straight up, all the color information is coming straight from the color map. Like, it's not getting lit, it's not getting processed, it's nothing but pure color. And after all, we're just drawing pixels to the screen. Easy to forget. We have almost finished this level, which is kind of cool. There's just one very important part left. Now, it's important to mention that while we're making a level, we'd be playing it again and again and again. I haven't even run it in-game yet. I'll admit to making this tutorial at a point where the tools were a little bit erratic because it was between projects. So my ability to get in-game was limited, so I decided to only do it once. But as a good workflow, getting it in-game again and again and again, play it every step of the way is very important. What I'm doing right here is making collision. Because when we get into the game, Drake is going to fall straight through the world without this very simple mesh that's used for efficient collision. And it's very important to actually make collision mesh. A lot of people think, well, why can't you just collide with the world? And then you can imagine just all the problems with him grabbing every single tiny edge and taking cover on all sorts of weird things. Like, it's just way, way too complicated. Although I did apply collision directly to the ground as a temporary measure just to get it working, most of the collision is incredibly simple. Like, check this wall out. I am just taking this polygon and extruding it all the way around. Pretty much just trying to get where Drake's going to stop if he tries to move towards the wall. Ultimately, this kind of approach should be more accurate, say, in multiplayer, where every grenade bounce is very important. But for the vast majority of single-player levels, this is how they were done. So take a grenade, aim that grenade all the way around the level, and witness at how terrible it interacts with the environment. But as a player actually using grenades effectively, it won't come up very often. So this is one of those things where the time saved is well worth the bugs created. And the amount of memory saved as well. And the amount of calculation. There's a whole bunch of saved, like time. Just win-win-win, except when you throw a grenade and it bounces back in your face. If you saw that interface up a second ago, that was just our collision applicator called the Pate editor. And making it a collidable mesh is as simple as giving it a surface type. Notice I'm still keeping things very, very simple. Some prototypes also have collision built in. Like that car already has collision, and that wall does too. This is especially useful, although we have the ability to turn it off on a per instance basis, which is nice, because sometimes you don't want collision. Let's look at an example of collision in-game. Check it out. Some of it's probably more complicated than it should be. Drake actually IKs to the ground. Like, he doesn't actually IK to the collision, as long as there's collision there. And bullets actually hit the visible geometry, as long as they've hit collision first. So it's not that bad. That's why we can get away with such rough collision. Notice those edges, though. All those edges that I just showed in our debug display are automatically generated from the collision. And those ones on top of the truck, for instance, are cover edges. We have sort of an automatic system for all this in that edge grabs, anything you can interact with in the environment just simply with our core mechanics is automatically generated, which creates sort of our ability to quickly iterate on designs very quickly, but has its downsides, of course. I'm not sure what the last bit here is. Just kind of looking at it as a whole. We've pretty much finished. This is the view that the player is going to come in from. So we've got that kind of cool flow from the wires up above. And also, I'll skip near the end of this one. And if I can, which I can't. Oh, there we go. Let's look back at the actual mesh we created. And you remember a lot of this video was me creating new mesh. Like that small amount right there took up about 2 out of those 3 hours, just to emphasize how critically important it is to get a kind of a modular system going, and to get that modular system right, and create it in a way that lets you layer and combine and adapt to unique scenarios and design without having to create an entirely new piece. Because it is time consuming. It is very time consuming. So a lot of our focus is kind of like, how do we prototype this properly? And again, getting too creative with it can cause all sorts of problems. For example, imagine if I'd looked at those buildings and said, okay, all the windows are going to be individual pieces, all the facades, I'm going to stack multiple layers of different types, and they're all going to be interchangeable. And they're going to have be like Lego pieces, and I'm just going to create a billion different varieties of building. That would have just been too far and too complicated for like quick workflow. Ultimately, one big coherent building was the best way to go. But a lot of that's going to depend on what you're trying to achieve, your time, how much level you've got, the engine you're using. So it's sort of something you have to judge on a case-by-case basis. But if you get it wrong, it can cause a lot of problems. Now, before I started working in the industry, I was also kind of mystified by the process of, like, how do you get it in game? It's on this magical box. How did you get it to there? And why this might not be very interesting for most of you, it's just kind of something I would have wanted to know, so I'm going to indulge myself. So to get that level in game, now that we've finished it, now that we've put it all together in Maya, it's actually a simple case of setting it up in a database, saying, hey, that Maya file is part of this level. And then it's a case of saying, hey, build that Maya file. You don't actually have to say, hey. You do have to be kind. You say, build that level. And what building that level does is takes that Maya file and processes it into a format that the game can read properly. So it'll load it all. It'll process the shaders, the textures, the mesh, all the information to do with that in a way that the game then can read it with the run command. Notice that the name of my computer is T. Morrison at Scotty Dog, and that was a quip on the part of our IT guys because I am actually from Scotland. And launching the level is as simple as that. So let's take a look at all the hard work we have just done and take a look through this environment with Drake on our collision. First time run, it worked. Ooh, we've got a few holes there. No wide, that's a shame. There's our nice books and our grass. And this is actually after a lighting pass. A pretty generic one from Warzone, but it's amazing how lighting just ties everything together. We've got the real-time shadows coming from the wires. See those little brick pieces? Those brick pieces were rendered from high-res bricks, just like I said. Let's take a few fly-throughs. Man, that looks bad though right there. See though, fixating on the details? Most players would not let that be detrimental to this experience. Believe it or not, I'm actually using the thumbsticks on the PS3 controller for this. I could be a surgeon. Moving on, let's look at a few Dutch angled screenshots. They always make something look a little bit better. This would be the view we'd come into our environment from, so it's a pretty important one. And then some of the views you can kind of see I guess, the environment from. This kind of thing is important, especially if there's cover, especially if there are enemies, potentially. Oh, that didn't work the way I was hoping it did. I was planning on turning the volume off, and I'm not really quite sure how to do that. Anyone? Volume? Remote? A big enough earthquake, I'm sure it'll knock some of it out. Let's just do it this way. I forget, it's my laptop. I know how to use it. There we go. Alright, so let's go through this same environment again, but with kind of everything we've learned. All those moving pieces are foreground objects. Check out those little prototypes on the ground of rock pieces that will fade out. All these walls are facades of buildings. They don't have a back to them. They're made specifically, hey, that's our prototype that we used at that broken building. Telling some stories, ripped out kind of fence. Depth of field set by the lighting guys usually, but in this case the cutscene guys, because they're playing it on IGC. All those moving flags are also foreground objects. Simulated cloth. Jumped over a wall made of move mod brick pieces. Camera got kind of close there. Luckily the ground held up. I didn't want to get too overboard with it. All those crates in the distance using shaders to change their colors. Some physics objects around. I think it might actually be physics objects. Foreground bus. As we get closer, some stuff starts to fade in, but you barely see it because you're playing and you're going to shoot some dudes and break that guy's neck, I guess. Drake, you're so bloodthirsty. Taking cover on an automatically generated edge just from the collision being there. Although we do have control after it afterwards. All these shadows being done by proxies. That scene being composed for this view, and that initial kind of reveal view. The idea that we kind of know the player's going to be looking down that way. Notice how to the right of the bus, you see a continuous ground. Oh, well, Drake. I didn't know you could do that. Whoa, that's some kind of cool powers right there. That is, and actually, I wish I'd done it without a weapon because Drake does the yoga. It's pretty awesome, and only accessible to Naughty Dogs. So I bet you're all jealous. And let's, I guess, try to sum all of it up. In what I would call sort of 1,000 views of Warzone. And don't worry, it's not really going to be 1,000. It's not going to be that long. Concept for that piece we just went through. It was the block mesh. This was actually worked on consecutively at the same time as the art. Very, very different from what we ended up with. Like, what is that big block to the right? That doesn't... And then that big wall? Man, I'm glad we didn't make that exactly like that. That wouldn't have looked so good. The Maya scene, the final result, but let's kind of break that down into lots of different pieces. Here's the depth buffer. That's what I was talking about in eliminating overdraw. The entire scene is drawn to in a very simple way. This is a very fast pass to a depth buffer so that any pixels drawn after that are culled if they're behind something. It's really important for avoiding shader cost. Color maps. Notice how most of them don't have much detail painted in. Some of them do, like that noisy rubble on the ground underneath Drake and those bricks to the upper left that are used with the move mod pieces. Those are used just to kind of seam everything up properly, otherwise you'd see the seams. It's a worthwhile visual hit to hide the seams and the problems, because it's so much faster using that workflow. Also, something to keep in mind with color maps is that they should be, one, lighting kind of agnostic, like they shouldn't care about what lighting they end up going under. Don't make them for a specific time of day. Make them to work with the shader. And then something that's even more important is that they should have a nice bell curve. I actually wish that I had a slide for this, because getting a nice distribution of values in a color map is incredibly important to render the scene properly. Some of our biggest problems of when creative texture artists have made very, very kind of light textures next to very, very dark textures. And lighting that kind of scene is incredibly difficult. Ultimately, you can create the same contrast through less contrast in the map itself, and differences in the shader, and a few other things. Here's a normal map view. Naughty Dog's engine actually renders normal maps and depth maps at the same time, which can cause problems, especially with overdraw. It makes it worse doing that, but ultimately was the best balance between rendering the scene lots of times and not lots of times. Notice that only about 50% in this scene actually has normal maps. And that would be because this is one of the first scenes ever made in Uncharted 2. And we were optimizing it before the engine had been fully optimized. So we were seeing how far we could take it. It didn't take too much of a visual hit. The trick, though, is to add everything, to really just kind of bomb the frame rate, keeping in mind that you want everything to be as efficient as possible, and then reel back to get it in frame rate. It's an approach we take quite a lot. Levels in their development are sometimes running at 10 frames a second, but will be reeled back to hopefully very playably smooth frame rates. Let's look at spec. Actually, notice that much is actually specular. There's usually kind of little objects here and there. The overall ground doesn't have any spec. We'd have liked it, I think. Ultimately, all objects in the real world do have spec. But it's a little bit expensive. In fact, we learned that lesson, and for Uncharted 3, we also rendered spec on a new pass, which means we're always paying for it, and it's a little bit more usable. So you notice there will be more shiny things in Uncharted 3, and who doesn't like shiny things? This is the shadow buffer, talks about that. Just in lighting mode, this is lighting plus normal maps, which is a big part of lighting. Ambient occlusion maps on foreground objects. They don't have baked lighting, so they have a hand-baked ambient occlusion map quite often. These are all the foreground objects. They would be handled by the foreground team, except Drake. He would be handled by the character team. Some of them are physics objects, some of them are animated objects, some of them, like the sign you climb on and fall down, and some of them aren't foreground objects at all. They're actually particles. I forgot about those smoke bits in the distance. These are vertex blend values, so anything that shows up in this view has a blend shader on it. And this is the final result of that blend vertex value combined with a threshold map. Check out the line of rubble going down just here. This is a good example of it. In that one is the tarmac and one is the little shingle bits on it. Actually, this scene has the shadows missing. It's kind of hard to tell because it's also noisy, but the shadows really help simplify the scene a bit and actually add more interest in certain areas. Screen space ambient occlusion, which is often overlooked, can have a huge impact on the readability of the scene. Like, check out around Drake. Some of it's a little artifacted, but he looks a lot more pressed up against that, I guess, oven because of the screen space ambient occlusion than he would otherwise. And then adding fog, render settings, and the final result with the particles. So that is that scene decomposed to the nth degree. Hopefully useful. Oh, so we go even further. Wow, there's some more colors to see. This is how expensive a shader is. Something very important that is I don't think commonly taught is the expense of the shader is really relative to the number of pixels on screen you see of that shader. So if you have a little tiny expensive piece that's like, I guess the center of this wheel, or some of these are probably kind of taking up a lot of screen, so I'm a little worried about those. Drake, whew, he is expensive. But if I was seeing little pieces of red like there, it doesn't really matter. Not a big deal. But if the whole ground, a big piece here was red, that would be bad. This is a shader cost view, and the more pixels on screen a shader takes up, the more of an impact its cost has. This is bad vertex set view. So if something is an inefficient vertex set, like it's just too few verts, it will show up red. In this case, if you see lots of small pieces of red, like in this case, that's an easy optimization. All I'd have to do is remove one polygon from that, and it would be fewer vertex sets. Fade distances, instances. Now, any individual color here is an instance placed in the scene. But keep in mind things are move modded too, so individual pieces of these can also be moved. And then vertex sets, how they're actually broken down, rendered, and occluded by the engine. This is not vertex sets. This is lighting error color. Notice how that is not even lit. Our card in the background And notice how this one's completely blue, which means it's full of buried verts. Remember the vert cuts we put in earlier to make sure things got good lighting data? This is not getting good lighting data, but it never got picked up. We shipped the game with it because it was alpha blended, and alpha blending lights differently. Let's talk about portfolios. And I expect most people in this room are budding students of some kind. Yeah, there's lots of budding going on. It's kind of a weird term. I do a lot of the hiring for Naughty Dog, which means I can give you sort of first-hand insight, I suppose, into what I look for and what I want to see in a portfolio. Really, though, I'm just going to talk about environment modeling and texturing. Let's talk about environment modeling first. What I really want to see more of when people apply for environment modeling jobs is just 2 awesome high-res images of environments. Really. I know you want to put more in there. I know you have some work you did as a 5-year-old that you think is really great and special. And you want to put it on your portfolio. You're so proud of it. I don't want to see it. It's not because I don't like your work. It's because I need to know that your judgment of work is good, that you can prune and tell when something isn't meeting the bar. So in a way, and I put this at the last point, your portfolio is only as good as your worst piece. If you put that work from when you were 5, that's what's going to get all the attention. I'm going to sit around it with my fellow Naughty Dogs and we're going to laugh at you. But if you take it out, if you prune that portfolio to stuff that just says, wow, these environments are great, just these 2, then we'll really get all the focus on what matters. My favorite story, actually, a fellow who works at Naughty Dog now, he, right out of school, applied to Naughty Dog, and he sent in a tube with Inca markings on it, like it was all dressed up to be in the theme of the environment test. And it had inside it a very high-res image of his environment test. It was like really nicely printed, and we were all just so excited. Wow, someone sent us this interestingly presented test. And we looked at it together, and not only was it very well presented, it was incredibly good. So he got the job, no doubt about it. But he also had a very good portfolio. We looked at his portfolio, and all he had was his name and 2 environments. And both of them were very good, and they were quite different environments. And the reason I say 2 is because you can't really fit organic and inorganic and exterior and interior all into the same environment that well. And there's a lot of interest out there. But I will say 2 because you should be, when you're deciding what environments to make, be thinking of layered ideas. Like the Nepalese war zone was a lot of damaged buildings. It could have just been a Nepalese city. It could have had no damage. It could have had no overgrowth. It could have had none of these damaged stories to go with it. And not only are damaged things easier to make in terms of modularity, and that you can kind of take shortcuts and kind of jam things together in a way you might not be able to do if you're trying to make it kind of real-world form, but they are much richer and much more interesting. Gears, I think, was probably like they just went crazy with not only the detail, but the fact that it was layered detail, like the damage on top of it. And we did kind of the same thing. And I would advise trying to pick things like that for the environments you choose. So don't just make a cathedral. Make a cathedral that's had a meteor shower fall through it that then has overgrown over thousands of years and has had nyan cat peel rainbows all over it. Start layering those ideas because ultimately it's going to look better, it's going to be richer, it's going to be more of a challenge, and we're going to be more impressed. And those 2 high-res images, and high-res I mean resolution of pixels. I don't care about polygons so much. It's much more important that they look good and that they're composed nicely and that you thought a lot about the scene and the camera angle than, say, the optimization of that kind of thing. But if your wireframe is good, show it. You might as well. If some of your textures are good, show them separately, especially if you're applying for the texture artist position. But quite often it's not. I've seen 1,000 portfolios that have a wireframe display of their art. And I look at the wireframe and I'm like, wow, this was really just to show the wireframe, wasn't it? It's just like it's like a sort of a sci-fi kind of thing. You've seen all the movies where they do the wireframe thing, and you're like, yeah, I want to get that in there. but it looks bad, like the topology is bad. It better be good if you're going to show the wireframe. Otherwise, don't. It's not going to help you. Just like that, that drawing from when you were 5, or more recently. I didn't include the first environment I ever made on my environment portfolio, although mine was no shining example. I just know what I want to see now. Let's talk a little bit about what not to do. A little bit more about that. Do not do this. Please. I'm begging you. Don't have it hosted on some site and you have to put in a password and download it. It really can be a lot simpler than that. There's a lot of technology involved in making games, and you have to be pretty adept at adapting to it. If you can't figure out how to host a website or get someone else to host it for you, that is lots of points against you and points against my time. And I don't want to sound like a stickler. Oh, those people sending their portfolios in and they're not packaging them nicely for my pleasure. I don't want to sound like that. But I do look at a lot, and I also have games to make. So try to avoid this. For those who like pies, I guess in this case it would be a blueberry and a strawberry flavored pie. Concentrate on the blueberry, because that's what's going to get you a job as an environment artist. It really doesn't need to be more. Some people want to go for quantity rather than quality. It turns out, though, that quantity is easy. It just takes time. Quality is not so easy. Of course it takes time too, you need to put the investment, but you'd be much better off spending a year making 2 environments than you would a year making 20, because I'm probably not going to get past the first 3, to be harsh. And let's actually talk just about environment art tests in general. They do simulate what you'd be doing in the real environment, like what you'd be doing once you kind of get the job. And it's one of the reasons we don't really mind what kind of background you have, what kind of experience you've got. It comes into play. But ultimately, if you can prove you can do a great job on the environment test, we're not going to have too many hesitations about you doing a good job in the actual conditions. Like I was saying earlier, organic and inorganic. Like, we want to see both. We want to see amazing trees and amazing foliage, amazing moss. Hey, interact it with some crazy cool ruins and some crazy hard surfaces. The most kind of common portfolio I end up seeing, though, is just a list of objects. It's like, oh, here's a tree. Well, actually, not even a tree. I would like a tree. It's more like, here's a bucket, and here's a slightly differently shaped bucket. Like, to try not to make your portfolio a list of objects if you want to get into environment art. And I will say that objects is kind of is one of the harder fields to get into, because the process for creating any one object is so much more defined than the process for creating an entire environment. And let's talk about textures for a second. The same kind of applies. You want to see organic and inorganic textures. Like, we want to see a bunch of foliage, a bunch of leaves, moss, and kind of undergrowth and dirt and forest floors. But we also want to see kind of hard surfaces like metal and brick, and pick an environment that lets you interact all of those in interesting ways and really focus on the way the shaders play rather than, say, maybe the detail of the modeling. And impress us with your richly sculpted and painted color and normal maps. Key word sculpted. We see a lot of photo-derived or painted just in Photoshop. As a texture artist, you're really going to have to learn to deal with sculpted forms in ZBrush if you want to fit in at Naughty Dog. And you can apply for these tests and more at naughtydog.com. So, if you're feeling up for it when you're when you've fully budded, then please do. Now, wonder ties. What is that term I was using at the beginning? Ties being kind of a prototype. Now, wonder ties is a prototype you can instance over and over again. Like those bricks that I was using on the walls. They were just used everywhere. They were like fantastic to have. We could ruin a wall in 5 minutes as opposed to 5 hours. They were truly wonder ties. And another example, the train actually was 11 physical miles of track. You may be thinking, whoa, that's a lot of track. You're right, it is. But it was also heavily instanced. Not just instanced on a kind of like these wonder ties, like the bamboo that could be used everywhere, but like individual chunks of the track, like maybe 20, 30 meters of track would be instanced. again and again. So there's very little repetition until you get around the whole loop. So I just want to say thanks to everyone at Naughty Dog and some individuals who helped me out a lot with this presentation. And just to remind you again of what matters, your money. And my email addresses. If it's very specific to Naughty Dog and you don't want to reply, send it to my Naughty Dog one. And if it's not so specific and it's short and sweet and I'll be interested by it, send it to my Gmail one. But I do get a lot of mail and I do have a lot going on, like we all do. So don't expect anything, but I try to answer as many questions as I can. And I'm also in San Francisco for 2 days, and I have no plans. So do with that information what you will. I hope you all learned something, and I guess we'll do a Q&A followed by some portfolio reviews. So if anyone has any questions, please, I guess, form a line. Is there a mic other than mine that they can use? Oh, down there. I always love how enthusiastic people are to ask questions. Yeah, run to that line. I'm just going to get into that line myself and talk to myself.
I hate talking on the mic. Well, no, Chris is talking to him, so I don't want to.
All right, so those of you who want to ask questions, why don't you come up towards the front, and those who need to leave can leave now. We're going to do maybe about 15 minutes Q&A, and then we're going to negotiate around portfolio review. We do have, depending on how long Teagan wants to stay, we might be able to do a couple, but there might be another opportunity tomorrow. So come if you're interested in doing portfolio review, don't have your portfolio with you right now, you can come by my office in 180, 8th floor, and we'll let you know at that time when and where. Okay, so thank you all. And if you have a question, just raise your hand, and we'll give it away to Teagan.
Yeah, go for it.
Yeah, I just wanted to ask about the modular assets. How is it decided what's going to be created?
Usually by an individual artist. Actually, that kind of applies to most things. There's a very kind of sort of an individual just deciding to step up and make something happen. Usually anything that has a texture that has kind of that's imitating pieces, like so you're talking tiling surfaces, you're talking like broken wood slats, floorboards that are broken wood, bricks, rubble, all of that kind of thing has kind of a modular piece that the texture is trying to represent. So we end up turning that into those kind of move moddable pieces. If that answers your question.
Yeah.
Cool. Guy behind you.
Hi.
Hey.
I'm not sure if I could ask you this question. It's not really related to environments or texturing, but after seeing the trailer, I have a question about localization.
Uh-huh.
All right, in the trailer, Elena was a model, was presented in a Japanese product instead of the American model.
I'm sorry.
The model you present for Elena in the trailer is a Japanese version. So I'm asking, how important is it for localizing your model or your game?
Oh,
market?
Really? I mean, we want to cater to the world, I guess. But that doesn't necessarily mean we make entirely new models. Elena that's actually her for the whole world. She looks the same, and it's just the voices we change for localization and a few other things.
Actually, I have a next question.
Go for it.
You want to grab a drink afterwards?
Sure.
Nice.
Yeah, if anyone wants to join us, I guess. Although I might be a while looking at portfolios and stuff.
Hello?
Hey.
I was just wondering, over the years, I'm sure you got a lot of portfolios from the school. What did you think of the quality from our game department and 3D animation department?
I'm going to be incredibly honest with you here.
Feel free.
No, it's not. It reflects badly on me rather than you guys. Is that I haven't noticed any trends from any specific schools. I've tended to focus a lot on the environment test and the portfolio, and much less on which school you're coming from. Like ultimately, those things are going to have a much more impact on how you end up doing professionally than where you came from. So yeah, I couldn't tell you. That would be an interesting thing though, to look at all the tests by school and kind of break them down.
Yeah.
It would.
How do you do the UVs for all those models in the game environment?
The UVs?
Yeah.
How do I do the UVs? Are you talking specifically about the UVs you saw me doing and kind of while I was modeling, or do you just mean in general?
In general, yeah.
Are you saying like is there some kind of trick or some kind of plug-in? No, not really. Although I will say that more often than not, starting with a planar map or a kind of a cylindrical map or something similar to the object's shape, and then unfolding those UVs is the most effective way I found of doing them. So we don't really have much of a trick. Some people use, I think, is it Hedis? I think is the name of a plugin. I haven't used it myself, but usually Unfold is my go-to tool, in Maya at least.
Okay, thanks.
I was wondering what ways you see the industry changing and how you think it might be a good way to prepare for that, whatever change you may see.
That's an interesting question. I think that it's going to become more and more specialized. It's going to continue to do that. Jobs are going to split. And I know that doesn't sit well with most people, myself included, because I like to do a lot of different things. But I think at a point once we reach kind of this maybe photorealistic kind of with ease kind of stage, when we get very streamlined, then it'll start going the opposite way. I mean, like right now, as an individual, you can go purchase a very cheap camera and actually make a movie, a very professional, good-looking movie for very cheap. And there was this kind of, I guess, this ramp back towards empowering the individuals and the indie teams to create more as an individual than you could ever before. So I think it's kind of this like dual kind of direction that's going to go in that sense. Do you mean perhaps in terms of hardware, just in terms of graphical?
In terms of the way you interact with your team and where the games are going.
Can you repeat the question, sorry?
How the industry is changing. So I suppose ways in which your approach to making a game and shipping it to an audience would change.
Like in terms of just how we work as a team, we're definitely getting bigger. We're a bigger studio now than we've ever been, and with that, I think has come some necessary changes. We want to maintain that kind of that garage feel, that free flow of ideas. Like we encourage people to go talk to the person involved with any one aspect they want to know about or change about the game, rather than having to go through some hierarchy. And we've ever set on the idea that we don't have producers, in that we kind of operate on our own terms and our own schedules, and we leave a lot of power to the individual. But the bigger games get, I think, the more structured that is going to have to become ultimately, and sort of the less you can maintain that. But we are struggling hard to maintain that, because I think a lot of creativity comes out of that free flow of ideas and that individual artistic empowerment. In fact, the way it works now really is still, hey, you've got this amount of time, usually a lot of time, like half a year kind of thing. You've got this one look, you're gonna own it, it's gonna be yours all the way up to the end. And sort of you divide how you spend your time within that. Like you have to kind of figure that out. You have to pull all the strings that are going to make what you're working on possible. So I do see that coming, I guess, getting harder and harder, but we still want to maintain it. If that answers your question, you want to be more specific?
That's great. Thank you.
Cool.
I have two small questions.
Go for it. One at a time, though.
First of all, most of us are in San Francisco right now, so we're centrally located. But if you're applying on the applying scale, if you're applying from, say, somewhere else in the United States, does that impact your chances if you don't live locally?
I'm going to say no, just because